grade 12 mathematics past papers. So that's basically what we go through on this channel from start to finish. So if you're doing mathematics grade 12, or you're looking for maths past papers, or if you're basically just trying to go through the metric math syllabus, then yeah, you're definitely in the right place, because on this channel we basically work on grade 12 mathematics questions and answers. It's basically like a memo channel basically. So this is, the first video, so it's going to be scruffy and all that, but let's just jump right into it. So the first paper we have here is from November 2019. Paper 150 marks, 3 hours, all the shandies. So let's get it. Okay, question 1. We have to solve for x, and then this is the equation that we're given. So we know that with all our papers, things always start off nice and friendly. So with a question like this, you can either use the quadratic formula or you can factorize normally. It's basically your choice. I always like the quadratic formula. I literally use it for absolutely everything, so I might as well use it for this question as well. So minus b plus minus b squared minus 4ac over 2a, you see. And then if I throw in all my values here, b, let's see there, and then when you use your quadratic formula, the main issue is that you just want to make sure that you take note of your signs and stuff like that. So the other main idea with all your past papers is you don't want to, or rather with all your metric papers, you don't want to take anything for granted. There's no question that you can say is like too easy or anything like that. So every single mark counts, and you obviously want to always double check your answers. Like here, if we throw in our values for x into our expression there, we should end up with a value for 0, and if you throw in those values into this expression, you'll definitely end up with a 0. So this is already how many marks there? 3 marks in the bag. So mentally, I'm sure you'll be always thinking of stuff like that. How many marks do I have now? which is cool. So 1.1.2, and you'll check even the pace that I'm going to be doing this at. This is the idea in an exam. You obviously don't want to rush, because you have all the time in the world or not. But you do have time to just dial in and not make any silly mistakes. And feel free to always rewrite the quadratic formula if you are going to use it, because if it's going to get you some marks, then that's perfect. If it doesn't, that's also still fine, because it'll basically be a way for you to avoid making any silly mistakes. So we have here b plus minus b squared minus 4a c, and then the whole thing over 2a, you see. So all these values, obviously in your calculator, you just want to throw in everything, and then we are getting here an x value of negative 1.5542. However, they said we should round it off to 2 decimal places, so this is going to be negative 1.55, or your x value is going to be equal to no, that runs a positive number. The second one is a positive number, which is 0.80. There we go. Perfect. So this is basically let's see how many marks more here. 3 more. So this is fantastic. It's 6 marks now. So the other thing with these videos is, if you want to jump straight to like a specific question or a topic, you can just double check in the description there. There's basically timestamps of where I started working on like specific topics and stuff like that. So here we have an inequalities question, right? 1.1.3. It says here 4x squared, let's put that there, 4x squared minus 1, where is it smaller than 0? So with a question like this one, right, what you want to take note of is that this is a quadratic equation. We can work this out algebraically, yes. However, what you want to get used to is to always remember that this is a quadratic equation. You see, this is a positive quadratic equation that has been moved down 1 unit. So automatically you can imagine that your parabola looks like that. You see, there is no shift from left to right. You see there's no value directly next to x with the whole thing squared. So this graph has not been moved from left to right. It has only been moved 1 unit downwards. So this is automatically our sketch, and don't mind the y-axis. That's not very necessary right now. So while we have these two pictures, what we can do first for ourselves here is we want to just work out our intercepts, our roots, right? So to do that, you want to work out where this value is equal to 0. Just keep in mind this is your main question, yes, but get the roots of your equation first. You see, that will always help you, especially if you're dealing with a quadratic equation. So what that means is the 1 goes over, this is like 4 squared, and then we know if you divide by 4 on both sides, this is going to give you 4 under a 1 there. X squared is equal to a quarter. If you square root both sides, you are seeing here that your answer is plus or minus the square root of a quarter. So obviously, I mean, the square root of a quarter, if you have a plus or minus, this is basically telling you that on the left hand side, this is basically a negative a half. And then on the right hand side, this is positive a half. So in terms of you answering your question, you see, this is not your answer. This question is asking you, where is your graph below 0? You see, where is your parabola? Below 0. So we can see that our parabola is below 0 here. You see, these points here that I'm coloring are the points where our graph is below 0, you see. And we can see our graph is below 0 from negative a half all the way until positive a half. And we should give our answer in terms of x. So we should say here that our x values, clearly they need to be bigger than negative a half. You see, our x values need to be bigger than negative a half. And then those same x values need to be smaller than a positive a half. They need to be smaller than a positive a half. And we are saying x needs to be bigger than negative half and x needs to be smaller than a half without an extra line here, because that's how our question is given. So this is your final answer. You can have like an arrow there for yourself. So yeah, that's how you can go about making sure that your inequality signs are properly put there. So yeah, moving on, because there's really no time to waste in an exam. You literally just want to be on your toes as best as you can. But you also, again, don't want to put yourself in a position where you just rush and you think that, you know, the time is out to get you, because honestly speaking, it is not. You have literally all the time in the world, hypothetically speaking. But anyways, this question now, it looks weird, because obviously there it says we technically still need to solve for x. But for a question like this one, the one thing that you want to keep in mind is that these square root symbols that we have here, right, this, we have like an expression here, this is clearly another expression there, where is this equal to x? So the one thing to take away from this question is that we are practically dealing with the difference of two squares. If you want to look at it in another light, what I mean is, firstly, let's just rewrite this question on a new piece of paper. So yeah, obviously what you will notice, these videos are not going to be, you know, nice and polished and all that. They are literally just knowledge on knowledge on knowledge, because, you know, there's nothing pretty about a maths exam. It's just, you know, So with this question, we have square root of 32 plus x. And that whole thing, the one thing to take note of is it is in a bracket and the whole thing under square root. And then we have the square root of 32 with negative x next to it with a big square root symbol above both of them. So when you are looking at this expression, right, this is one thing to take note of. Can you see that this is basically telling you that you have one thing here, which is like 1 This is one term, this is another term, but they are both under a square root, you see. And then that whole thing is being multiplied by square root of 32 minus x. That's also under a square root. Now, a rule of thumb is, well, this is equal to x, which is fine. Now, the one thing to take away from this question is that, firstly, big issue. This square root here and this square root here, let's just put it like this. If you have a square root here, right, with like a blob, and then it is being multiplied by a square root with another blob, you see, because these two are both under square roots, and because they are being multiplied together, you can put them both under one big square root symbol. You see, this here is representing what we have over there. This here is representing what we have over there. So because they are both under square roots completely, we can just put them both under one big square root symbol. So let's do that. That's the first thing we can do towards answering this question, to prove that it is actually not bad at all. So we technically have the square root of 32 plus x. This is one thing. It is being multiplied by square root of 32. There we go. That whole thing is equal to x. You see, that looks a bit better, because at this point in time, you can clearly see that all we need to do is to square the left and square the right to get rid of the big square root. So if you square the left, before you do that actually, I think you may want to work with what's inside this square root symbol first. You see, that's going to make life a bit easier. So we have the big square root symbol there, and don't be scared of square roots. They're just square roots. I mean, you're a whole human being. This is just a line, a weird looking line anyway, so you can't be scared of stuff like this. Yeah, dry jokes. So here we have a bracket and another bracket. So technically square root of 32 times square root of 32 in your calculator, that's just going to give you 32. Or rather anything under square root, right? If you multiply it by itself, it's just going to give you the value inside. That's like something you can always remember. So square root of 32 times negative x, you have negative x square root of 32. And then here x times that, that's a positive x square root of 32. And then x, which is a positive times x, which is a negative, is just going to give you a negative x squared, you see. And then these two just go away because they are the same. They have opposite signs. So yeah. Okay, so here now we have a big square root with 32 here minus x squared equal to x. And then you see here things are definitely much easier now, because look, this is how it started, but we have managed to break it down. And this is a 4-mark question, by the way, in this 2019 November paper, right? It's your Department of your Department of Basic Education, November 2019, paper 1, your memo. So we just need to square both sides here. If you square the left, we technically have this squared, that squared. This will cancel your third, and then this is giving you 32 minus x squared equal to x squared. So here we are. It seems like, well, we didn't take long to get here actually. It was okay. So the good news is we can obviously take the x squareds to one side. This is going to be x squared plus x squared, which is 32. And then this is obviously 2x squared, which is equal to 32. Divide both sides by your x here. This is going to be 16x squared. And then you're home free here, because if you square it both sides, x is equal to plus or minus 4. Never forget your plus or your minus. You see, this is one of those things that will lose you your extra mark in an exam when you were like killing it. You know, you have like 79% there because you forgot to put a plus or a minus at the end of a question. You don't want to put yourself in those kinds of situations. That's really bad. That's like super sad. So this is our solution. The only thing now is you want to re-look at your solutions and ask yourself, is a positive 4 and a negative 4, are they both valid solutions? The reason we would want to ask that question is, you see here we're working with surds, and anytime we work with surds, we know that negative answers are usually a problem. So what you want to do for yourself is throw, let's say, positive. If you throw positive 4 into each of these, that should be fine, because positive 4 is a number that is originally I just dropped something. Positive 4 is a number that is originally bigger than 4 anyway. So positive 4 is definitely a solution. Let me just pick up my pen quickly. Yep. Picking up. There we go. Got the pen. Oh yeah, like I told you, these are going to be sloppy. But the best part is they are going to be memos from start to finish without any, interruptions, because why? Hopefully. Anyways, so if you throw a -4 here, you will note that here, let's try a -4. -4 here, we know that this will be fine. You will have a positive number in your expression. And then -4 here, let's see. So the big idea is that, remember, our expression says where is the left side equal to the right hand side. So the only issue is if you put a -4 there, right, this is going to give you a positive number, and I squared it. If you put a -4 here, it's going to be -4. So the whole thing here is going to give you a positive number, blah, blah, blah. So the left side will always be positive. However, if the left side is a positive and the right hand side is a -4 there, you see the equation will not balance. So in our case here, x cannot be equal to -4. You can just double check for yourself here. Quickly pause the video if you want. Throw in -4 there, throw in -4. You will note that that expression will not be equal to -4 on the right hand side. So yeah, moving on. Because, we only technically have 3, 6, 9, 10, 11, 12, 13 marks, which is not too bad, but it is less than 10% of the paper. So you would need to definitely keep on going, because these papers take 0 prisoners. However, this is the way that you're going to just chop stuff, these memos, or rather these past papers that we're going to be going through on this channel. So moving on to the next question without wasting anybody's time, we have here 1.2. 1.2 is a simultaneous equation question. It's for 5 marks. It says here, solve simultaneously for x. Hey, why are you so blurry? There we go. Solve simultaneously for x and y. And then it says the y plus x is equal to 12. And then xy is equal to 14 minus 3x. So that seems like a fair question, I guess. Nothing too aggressive over there. So as we mentioned already, right, you never ever, I think I've said ever too many times now. Well, I think we can still say it one more time. You never ever want to underestimate any question in an exam, ever. Again, I'll repeat, those are the things that will get you a 69 when you could have gotten a 70. The things that would get you a 79 when you could have gotten an 80. Underestimating a question, thinking that, oh, I know this, I know how to do this, and then you just jump into it, and then you miss a sign here, and then the next thing you know, you don't have a distinction. So yeah, this is how you can avoid those kinds of situations. Just treat every question like it needs your full attention. So let's get it. This here, if we're going to solve for y and x simultaneously, obviously in grade 12, elimination is going to be the last thing you want to think of, because you can almost think of it as an expired method. So here I've decided to choose x as our subject of the formula, because it looks as though it may be easier for us to throw. Well, technically here, actually, I'm going to pivot here. I'm going to make y the subject of the formula. The reason why I'm going to make y the subject of the formula is because there's only one slot to put y in our equation here. Whereas for x, there would have been 2 slots. You see, that's like more work. So you can see what I did there. It's okay to pivot. It's okay to change your mind. So here, if I make y the subject of the formula, it's going to be y is equal to 12 minus x. You see, taking note of our signs, because if x goes over, this is going to be a negative. Now for this here, so this is technically one of our equations. This is our second one. So if you want to label this 1 and you want to label this 2, that's perfectly fine. So we're going to take 1 and throw it into 2. So you technically have here x with 12 minus x equal to 14 minus 3 with x there. You see, I was about to throw in something there. That was going to be a mistake, but you see, there's x there, there's negative 3, there's 14, and you see what I'm doing? Just double checking every step, because you never want to take anything for granted. You see, you're gonna regret it. So here, if you multiply our x inside, we have 12x minus x squared equal to 14 minus 3x, and then we have, let's take the x squared to the other side, because it's always nice to work with x squared. That's a positive. And then the 12, if it goes over, that's going to be negative 12x there. And then the 14, that's still just a positive number. And then let's see what we have here. Here it's technically, let's do this. Whoa, why are you being so dark? Oh, that's so nice. This is so much brighter now. Let's see if I do this. Ooh, nice and bright. Okay, let's keep it like this for a bit. I'm wasting time here. You see it in exam. Don't get distracted. So this is x squared minus 15x plus 14. So again, this is one thing you'll hear me say a lot in these past papers. The quadratic formula saves lives. Like, oh, use it whenever you want to. Use it wherever you can. You see, it will save you. However, here, we know that if you want to factorize this, right, you will see that you technically need two terms, or rather two numbers, which are what you call factors of 14, that will give you 15. So it's just 14 and 1 technically, because 14 times 1 gives you 14. However, this is a negative 15, so you want to ask yourself, a big number and a small number, for you to get a negative 15, well, you technically need to have a negative 14 and a negative 1, you see, because negative 14 minus 1 is going to give you a negative 15. So this is all you would need to do to factorize this. And we said if you don't like factorizing, just use the quadratic formula. It will save your life. So here we know that this is technically telling us that the first bracket is equal to 0, which is going to tell us that x is equal to 14, or the second bracket is equal to 0, which is going to tell us that x is a positive 1. Yeah, you see, easy marks, so you have your values for x, so you technically just want to throw those into one of your equations up there and get values for y. So obviously it's easier to throw it into this one here. So in our equations, right, in our equation there, we know that y plus x, let's choose x as 14. This is going to be 14 equal to 12. And then here you're getting that y is equal to 12 minus 14, which is definitely telling us that our y value there is going to be a negative 2. So you do that again with your other y value, right? Which in our case here, let's see, our other y value, our other x value is a positive 1, you see. So this is going to be y plus x, which is a 1. So we have plus 1 here. The whole thing is equal to 12. This is going to be 12 minus 1. Clearly, your y value is going to be 11. So you see, you have all your solutions everywhere on your answer sheet. That's perfectly fine. You don't have to worry about, making it look pretty and all that. Nope. You don't get marks for having question papers that look pretty. You get marks for giving correct answers. If you look at my handwriting, it's the worst. Yeah, it's super bad, but this handwriting got me a distinction, so woohoo! Moving on. So, the next question. Our next question here is 1 point. Yay, it's so bright. There we go. 1.3. So 1.3 it looks like one of those questions that just make you go, come on. I was having a nice paper. Where is this coming from, type of thing. So I totally get it. Yeah, it's not the nicest questions to look at. It's not the nicest questions to have. Well, it is for 4 marks though. You see, if you look nicely there, it is just a 4-mark question. So for this 4-mark question, it says, consider the product 1 times 2 times 3 times 4 going all the way until 30. So this is almost like 30 factorial in reverse, you see, because it's 30 multiplied by every number before 30. And then it says you determine the largest value of k such that 3 to the power of k is a factor of this product. Woo! So obviously, when you are looking at this question, the one thing that comes to mind is what in the world is actually going on? If that's the kind of reaction you get to a question like this in an exam, seeing that you would be so early on into the paper, well, you obviously would want to skip this question and then come back to it. You see, you don't want to skip everything indefinitely. You always want to skip and then come back if it is a question that is not very nice for you. If it does not make you feel good, you skip it. But we are going to go through it, right? So what you want to do for this question is you just want to think to yourself, firstly, we know that if any number is going to be, it says you consider the product, which is consider whatever answer this gives us. Determine the largest value of k such that 3 to the power of k is a factor of this product. So we know that 3 to the power of k refers to 3 multiplied by itself a certain number of times. So you basically would want to think to yourself, how many times can we multiply 3 by itself and still, no. You want to ask yourself, how many times can we multiply by 3 by itself such that whatever answer we get is going to be a number that can go into our product here, right, without leaving a remainder. So the one thing you want to do is you want to think of multiplying by 3 a certain number of times. So to do that, so to make this easier for yourself, this is going to save your life. You want to think to yourself that you see these numbers within this product. There are certain numbers within this product that 3 will be able to go into. So you basically want to go about this question in this manner. You firstly want to ask yourself, let's put here, what's this number now? 1.3. 1.3. You want to ask yourself 3 times 1. 3 times 1. We know that this is going to give you a 3. You see, and 3 is a value within this expression, so that's once. And then you want to go 3 times 2. This is going to give you a 6. Let's put here 3 times 4, 3 times 5, 3 times 6 is basically 3 times 2. And then 3 times 7, 3 times 7, let's put here 3 times 8. 8 is not a value divisible by 3, so that's fine. 3 times 9, 9 is 3 times 3. And then 10, let's see here, 3 times 10. 10 is not a number that is divisible by 3. Let's try the, well, this is basically where you'd want to end off. So we said here, in our expression, right, you want to, where did my question go? In our expression, right, you want to work out how many numbers within this sequence are going to be divisible by 3. And to take note of all those numbers, we said here you're going to start off by saying 3 times 1 is 3, 3 times 2 is 6, 3 times 4, what is 3 times 4 is a 12, 3 times this is 15. The answers really don't matter, right? But let's just throw in those answers there. 15, 12, and then the next one is going to be 18, then the next one is going to be 21, the next one is going to be 24. And again, if this is the kind of question that you would automatically skip in an exam, the good news is you can just skip over to the next question as well. Because the one thing you want to take note of in an exam is you are timed anyway. So you don't want to waste your time on something that is going to stress you out to the point where you end up leaving marks on the table of things that you are comfortable with, you see. So here we just said we're going to lay this out, and then you basically want to count how many times does 3 appear here. 3 technically occurs 1, 2, 3, 4, and then 5, 6, 7, 8, 9, 10, 11, 12. Ooh. Well, we have 12 here. So in counting these, the one thing that definitely comes to mind, woo, where is all this light coming from? Oh my gosh. Oh, there we go. So in counting these, right, the one thing, if you take note of what we said here, if you look closely, you see I skipped 3 there because it's 3 times 1, 2. There's supposed to be 3 there, you see. So here, technically, 3 times 3 would be there as well. So if we count our 3's again, it would be 12 3's and then 13, 14 3's, you see. There we go. So, to answer our question, they said consider the product, this. They say determine the largest value of k such that 3 to the power of k is a factor of this product. So all we need to do is we need to ask ourselves how many numbers within this sequence are going to be factors of 3 technically. Yeah, how many numbers in this expression will 3 be able to go into? So we said all you do is you lay out multiples of 3, as many as you can, obviously until 30. And then we said 3 times 1 all the way to 3 times 10. We can break this up into values multiplied by 3. So you see here 3 times 1 is a 3, 3 times 2, 3 times 3, 3 times 4. When we go to 3 times 6, 6 can be multiplied by 3. So you need to lay it out like that. 9 can be gotten by multiplying 3, so you need to lay those out. 10 not. And then we just counted the 3's here. So if this question was was having multiples from 1 to 40, and they asked determine the largest value of k such that 4 to the power of k is a factor, then you would lay out values of 4 times itself all the way until 10, and then every number that you can write as 4 times something, you would do that, and then you count the 4's. And we said if these are the kinds of questions that you would not like to see in an exam, or the kinds of questions that would just stress you out, don't attempt them. It's best for you to go and do other things, and then when you're fully done, you come back to them. You see, it's that simple. If you don't get time to come back to them, don't stress about it. Remember, you have 2 papers to get your math mark. So yeah. Question 2, right, is a quadratic sequence numbers question, or a quadratic sequence question. Wow. It says here, given the quadratic sequence, we have a quadratic sequence. The one thing we know about a quadratic sequence is that it is a second common difference. So with the question that we just went through, this was basically worth 22 marks, you see. So in our question paper, we technically have 22 out of 150. Woohoo! That's good. You should always remember that, you know, your marks, you want to take note. You want to take note of them in an exam. It will keep you motivated, you see. So in our quadratic sequence, right, they said here, clearly this is decreasing, which is fine. But they said you write down the values of the next 2 terms. So the one thing to take away from this question is clearly it is a quadratic number pattern. So anytime you have a quadratic number pattern, you want to remember what makes up a quadratic number pattern. Remember, a quadratic number pattern just means that your pattern has a second common difference. So if we're going to work out the next 2 terms, obviously all you want to do is you want to ask yourself, what is the difference between these values? And if you use your calculator, you see that the difference between these 2 numbers is basically 31, or rather negative 31. This is negative 29. This is negative 27. And then you want to look for a trend. You see here, these values are basically just increasing by 2. You see here, so if you increase this one by 2, that's going to be negative 25. And then if you increase that by 2, that's going to be negative 23, you see. And all that's happening is, can you see, this value minus this gives you that, minus that, or rather plus. This value plus this gives you that, plus this gives you that, plus this gives you that, plus this is going to give you a value here. Now in your calculator, this is going to give you 209. And then if you add negative 23, that's going to give you this value as 186. So this will give you your 2 marks, easy 2 marks. Remember, we said no mark is too small, so try and celebrate with every mark that you get. Remember, an exam is one of the most loneliest things. You can't talk to anybody, you know, so yeah, whatever is getting your marks, be happy, you know, smile about it and move on. So the next question, right, basically says determine the general term of the sequence in the form Tn is equal to an squared plus bn plus c. So remember, if you want to go through a specific question in this paper, just look in the timestamps and then, no, look in the description. There are timestamps there of when we did whatever question. So yeah, getting the general term of a sequence is going to be getting the general term of a sequence needs to be one of those questions that you always get marks for. The reason I'm saying this is, well, obviously your papers are the same forever and ever, unless they change the syllabus, which will be nice, and take out Euclidean geometry. That would be nice. Let me know in the comments if you agree that Euclidean geometry should just be taken out of the syllabus, because, why is it there, you know? But anyway, so we need to get the general term of our sequence. So for us to get the general term, we need to think of a formula, or rather we need to think of a method. So the method we use is, you firstly, my things are cramped and my handwriting, oh my gosh. Let me know if you have a worse handwriting than this. I doubt you do. I think if we ever have like a worst handwriting competition, I would win. But anyway, so for us to get our general term, the first thing you need is your first differences. After getting your first differences, you actually need to get your second common difference, because that's what actually, helps you get your general term here. So our second common difference, if you check, we already said that this is just 2, 2, 2. Once you have laid that out, to get A, B, and C, this is what you do. Right at the bottom here, your second common difference. This you equate it to 2A. The first number in your first differences, you equate that to 3A plus B. You see, like that. And then the first term in your original sequence, you equate that to A plus B plus C. Yeah, it's not very pretty. And remember, we said your stuff needs to be clear in an exam. You see, if it's visible, if it's clear what you're doing, you're safe. Don't worry about making it look like a fairy tale, because we said that doesn't get you the marks. But anyways, I'm not saying you should write unneatly and make it ugly. No. I'm just gonna say, yeah, just be free, So anyways, yeah, like this handwriting got me a distinction. So if your handwriting is bad, don't worry about it. You're fine. So here 2A is equal to 2, right? So here we technically, you need to now work these equations out from the bottom to get A, B, and C. So here we have 2A is equal to 2, which is technically just A is 1. Sorry, you couldn't see that, but you can now. So yeah, 2A we divided by 2, divided by 2A is just a 1. Perfecto. You keep moving on. You see, your second equation there has 3A plus B equal to negative 31. Now, because you have A, you just throw that in there. And then working out your value for B, it's going to be negative 31 minus 3. This is clearly just going to give you negative 34. So, yeah, you see, you're doing good at this point. You see, you are almost there. Because all you need now is your value for C. Now, to get your value for C, you do same thing, really. A plus B plus C, you know that is equal to 321. And then if you have A, which is 1, B is negative 34, C you don't know, but then the whole thing is equal to 321. You know that here this is technically going to give you a negative 33 plus C. And then if you take that to the other side, your value for C is just going to be 354, because you see this number you add it when you take it to the other side. So seeing that our value for C is such a big number, you may be thinking, why is it so big? Well, it's fine, because look, our sequence has values that have 3 digits anyway, so this value for C is not out of place. So you then want to give your final answer though. For a question like this one, try not to leave it as A, B, and C only. Try to have your final solution, or your final term, or your final general term here, you see, to make sure that you don't run into any funny problems where you are like one mark short. And yeah, I'm going to start sounding like a broken telephone here, but yeah, you don't want to end up there 1 mark short of a distinction. That's like, the worst. But anyways, so C here is a positive 354. There we go. So this is going to give you 4 more marks. So you get your 4 marks. You have like a mini victory dance without making any noise for anyone, without distracting anyone. in your in your exam, and then you move on, you see, because yeah, you need that. You need to have light moments in your exam. Don't just be gloomy the whole time. That's going to, yeah, your brain is not going to function at its optimum. So 2.1.3, it basically says there which terms of the sequence will have a value of 74. This is a 4-mark question. So keyword here is terms, you see. Which terms of the sequence will have a value of positive 74? Now, the idea is with our sequence, this is clearly reminding you of a parabola, you see. So this is technically telling us that firstly, we have a positive parabola here. So what it means is our numbers, they increase, and then they start dropping, you see. So when they ask us here, which terms in the sequence, which terms of the sequence will have a value of 74? What they mean is somewhere in the sequence here, there's a value of 74. And then somewhere on the sequence here, when it decreases again, there's also a value of 74. So, I mean, this one is an easy question for 4 marks. All you want to do is in your sequence, you basically know that you are dealing with a value that is equal to 74. So that goes where Tn is. You see, they didn't ask for the sequence in the 74th position. No, they asked which terms of the sequence will have a value of 74. You see, so they want an actual value and not the position 74. They're saying the actual value is 74, and then we need to find, let's finesse this. The actual value is 74, and then we need to find the position where, why do I keep making mistakes now? Wow, this is very common of me. If you like follow my math page, you'll see that. But anyways, we move. We always make it work. And remember, you don't have TPEX in an exam, so you also want to be used to finessing answers and stuff like that so that they're clear, you know. You can clearly see this is n squared minus 34n plus 30 plus 354. And we said in an exam, you don't get marked for neatness, so this is fine. If anyone marks you down for stuff like this, they should be jailed, sent to prison, because what the hell, right? So with 2.1.3, this is what you want to lay out, and clearly this is going to be a quadratic equation if you take the 74 to the other side. So this is n squared minus 34n plus 354 minus 74, and then this is n squared minus 34n. And then in an exam, try to avoid doing mental math. I know it sounds like something dumb or weird, but like, why? I'm training my brain, you know, to become stronger. Nope. Try and use your calculator for absolutely everything. Because remember, in an exam, there's this thing that happens to a brain. Sometimes it just makes these weird mistakes. So always use your calculator. This value, these two values in your calculator will give you 280. And then here, I would advise you to just use the quadratic formula. You see, n is equal to minus b plus minus b squared minus 4ac over 2a. So let me know if you like the quadratic formula. You know, just let me know in the comments how much you like the quadratic formula, because I like the quadratic formula 1000%. It literally saved my life or saves lives every day, all day, every day. So that's why I always use it. If people got paid for using the quadratic formula, I think I would be, yeah, amongst the richest guys that would have ever gotten some money from this, because I use this formula all the time because it's so safe, you know, because remember, in an exam, you don't know if something is factorizable or not. So instead of, you know, trying to factorize it and all that, just jump straight to the quadratic formula to get your answers. You see, that's a way of saving time. So you'll see, wow, that's the best thing about these past paper memo videos. They have bloopers everywhere, and those bloopers are not going to be edited because this is too long. So n is, what kind of a laugh was that? Oh wow, n is equal to 14 and n is equal to 20. So that's going to give you, let's double check here, 4 more marks. So you get those 4 marks and you keep celebrating. You keep, keeping a positive mental attitude. That's 2, that's 4 more, that's 4 more. So yeah, man, your hard work is paying off. So it says here, Which term in the sequence has the least value? Okay, this is where you may be thinking, oh my word, what is actually going on? Like, why are you doing this to me? I thought we were having fun. I thought we were friends. Well, a question like this should not upset you, because remember, we know that in grade 12, anytime we see stuff like least value, maximum value, blah blah blah, you want to think of differentiation. So if they want to determine the sequence that has the least value, you need a specific value for n that will result in you having the least value. So for you to get the value of n in this sequence, or rather the value of n in this sequence that will result in the least value, you would need to differentiate this equation once and then equate it to 0 to find that specific n value. The moment you find that specific n value, you then come back to this equation and throw that there and find that actual least value. So what we are going to do is get us another clean papira, so another clean page. Okay, so we have another clean page, and here what we technically need to make use of is our previous answer. So we know that Tn is equal to n squared minus 34n plus 354. If you're wondering what this is my math page on IG. So basically what I do on that math page is, well, whenever people ask me math questions, if they're like, then I make quick, short tutorials of them, and then I basically post them on this math page. So that's basically what I do, in case you're wondering what zero aesthetics just mathematics is. So by the way, there's no E here because I spelled that incorrectly because I'm terrible at spelling, but I just left it because you know, it's just one of those things, whatever, it's just a word. Oh wow. So here we need to get the term in the sequence that is the least value. Which term in the sequence has the least value? Okay, so key thing here is they said which term in the sequence has the least value. They did not ask which value in the sequence has the or rather they did not ask which value in the sequence is the least. You see, those are two different questions. And again, that's the best part about making sure you go and reread your questions to be sure before you start answering them. Because you see, this question says which term in the sequence has the least value. It is not asking what is the least value in the sequence, you see. So we just need the position where the least term is occurring. So we're still going to work out a value for n after differentiating though. However, that value for n is going to be our final answer. You see, if they want us to then get the exact value that is the least in our sequence, then we would make use of that n. But for our case, we don't have to. So here we said to get an answer for 2.1.4. So 2.1.4. And if you want a copy of this paper, it's everywhere on the internet. If you just search the grade 12 mathematics past papers, you can go to whatever website you're comfortable with and then download the paper, you know. So here we said we need to differentiate this equation once. So differentiating this equation once, what you want to put there is something like dn with like a square bracket, and then this here. This is to show that you are about to differentiate your expression. And anytime you're about to differentiate, if you don't, you can put it like this to show that you're about to differentiate, you see. Or you could literally just do nothing. You can just jump straight to differentiating it, but then make sure that you put something like this as your final answer. You see, this is, well, where are you going, pen? Come back, I need to write. So, yeah, excuse me. Yeah, I'm going to be saying a lot of dumb stuff just to keep things light because exams are serious, way too serious. So here, if you differentiate this, right, it's going to be 2 times the value in front, which is just 2n. And then if you differentiate this term, it's just going to be negative 34. And then this here, it's a constant, so you cannot differentiate this. It just goes away, you see. If you're not familiar with differentiating, I mean, if you check on my other channel, because I have two channels, but on my other channel, right, that's like full-blown tutorials, you see, where I like, and the setup is way different, you see, I like right on the screen and stuff like that. Let's see where the camera is. Yeah, like right on the screen. It's pretty cool, I think. So on my other channel, right, where I like do main tutorials, where you can actually see me, it is called Bright Young Brains. You see, this is what we call a shameless plug. Brains. There we go, Bright Young Brains. But then if you're on this channel, you probably knew about it because of Bright Young Brains anyways. You see, this is like the parent channel. This is like the well, the daughter channel. Anyways, we have differentiated, and you want to equate this expression to 0, and then you can take this over. This is going to be 34. 2n, divide by 2 on both sides, n here is going to be 17. So this is telling us that the term in the sequence that has the least value is term number 17. So to just end things off, you can put here term 17 is the least term, or is the least term in the sequence. And remember, this is not English. Your words just need to make sense. If they're not grammatically correct, don't worry about it. As long as they make sense in terms of answering the question, and as long as your calculation backs them up, you are safe. You see, these are the kinds of things you don't want to stress about too much in an exam. You don't get marked down for like spelling error and stuff like that. Nope. Because your calculations are always there to help you out. So you said here term 17 is the least term in the sequence. And we said if they want you to then find out the actual least value, then because you know it is at position 17, you would just throw 17 into this equation, and then you would be home free. So moving on. So we got how many marks here? 2 more. Well, that's okay. You see, 1 mark, 2 marks, that's perfect. Don't worry about any marks that may just be too little. It doesn't matter. All marks are equal, but obviously some are more equal than others. If you do Animal Farm, you'll know what I mean, but I don't think you guys do Animal Farm, but it's fine. Given the geometric series, okay, we have a geometric series here, and we know a geometric series basically refers to a series that has a common ratio. So when something has a common ratio, it means that you are multiplying something constantly for you to be getting, you know, values in your sequence. So for 2.2, this first question is point blank saying that we are given this geometric series, right? It's a fraction, 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 and it's just fractions everywhere. And then because you see the value at the denominator position, you see these denominators are getting lower and lower and lower and lower and no. The denominators are getting bigger and bigger and bigger and bigger. However, the top is staying the same. So what that means is the values in this sequence are actually decreasing, you see, because that's how it works. If the numbers at the top are the same, but then the ones here are getting bigger and bigger and bigger, then your fraction is technically just, you know, getting smaller. So the first question here says, determine the value of k if the sequence has 21 terms. Okay. So the one thing to take a note, of, wow. I wanted to say the one thing to take note of is that, you see, this here is saying that all these values added together is equal to k. You see, k is not a value in the sequence. K is all this sequence added together. And here they have just told us that our sequence has 21 terms. So we technically need to add up the first 21 terms in this sequence. That's going to be our value for k. And you see, it's just a 3-mark question because they know that this question is not very fantastic. It's not very difficult or anything like that. So you just get your 3 marks and you keep moving forward, you know. Forward we go. So 2.2.1. We know that this is a general sequence, and because we need to add terms together, For this geometric sequence, you need to think of your SN formula, because remember your SN formula, you use that when you want to work out the sum of a certain number of terms. And remember, the good news is things like your SN formula will always be on your formula sheet. You see, your formula sheet is like, yeah, that thing saves lives as well. Way better. Well, technically the quadratic formula is on the formula sheet. So you see the formula sheet saves more lives than the quadratic formula itself. You see, the formula sheet is something you want to have with you even when you're studying and stuff, just so that, just in case you don't do that already, which would be weird. But anyways, to use this formula, we need the first term in the sequence, which we know it is just 5/8. You see, the first term in our sequence is just 5/8. And then our value for r is our common ratio. Remember, your common ratio will always be a certain term divided by the one before it, you see. So our value for r here, we can work it out by saying 5/16 divided by 5/8. So in your calculator, you can put there 5/16 over 5 over, no, it's 5/32. You see the universe wanted to rob me of my marks there. Oh, well, this is about to get weird. Well, not my marks, but you know what I mean. So if you put this in your calculator, technically what's going to happen is you have 5/32 divided by 5/16. So your calculator basically turns this into a multiplication sign. It flips this over, and then you technically have here, well, technically this 5 is going to cancel this 5. And this is only happening because you're multiplying, you see, because it's technically 5 times 16 and then 32 times 5. You see the 5 cancels the 5 there, you see. And then you just have 16/32, which is just a half. Boom. But this is not necessary. Just use your calculator. It's safer. Remember, we said try to avoid mental maths as best as you can in an exam, because you really don't get marks for it. And it's not safe. So A is just 5/8, 1 minus R, which is just a half. And then, whoa, you see, I forgot my N there. So you see what I was about to do? I was about to make a classic mistake, classic error. Because you see, I was about to put the N here, which is wrong. And this value for N is going with the R. So we need to work out the sum of the first 21 terms, you see. So the R has to be next to the N needs to be next to the R there. The whole thing here is over 1 minus a half. And then try and put this into your calculator very nicely. You see, when you're putting stuff in your calculator, well, obviously the last thing you would want to do is to rush, because, I mean, you're literally there. Why are you rushing? You get. So with your papers, you usually want to give your answers to 2 decimal places unless stated, unless stated otherwise. So this is just going to give you 1.25. Well, that's okay. I mean, it's a fraction technically. So you don't want to be too alarmed, because, I mean, this sequence has fractions anyway. So if you add up the first 21 terms, this is going to be the value if you round it off to 2 decimal places. So let's go. Ooh, we're about to hit the 1 hour mark. Yo. So in an exam, if you see that you're about to hit the 1 hour mark and you're still on question 2, yeah, you would be in a bit of trouble. Well, the only thing is, well, technically this is out of 19. The previous was out of 22. So this would technically be like, what is 9 plus 2? That's like, there's 11 here. So that's like 41 marks. So that's okay. That's okay. You see, because this is technically going to be 41 marks out of a full 150 papers. So this is okay. It's an okay pace. In an exam, if you're still here and there's an hour that has gone by, that's okay. You would just need to think to yourself, well, I really need to sort of pick up the pace and move a bit faster, because, yeah, time is not something you want to be afraid of, but it's also something you want to be conscious of. So let's see here. We got our 2.1. We got it. So that's 3 marks. Check. Now the next question. Is out of 4. And with a question like this one, you just want to be, just have a clear head when you look at it. So it says, determine the what? Well, it says determine the largest value of n for which Tn is bigger than 5 over 8,192. Wow. Well, that's a very tiny fraction. Well, anyways, with a question like this, it's actually quite straightforward because they say determine the largest value of n for which Tn is bigger than 5 over 8,192. So this is literally just 4 marks given away because it looks like a hard question, but it's not. Because all you want to do is, where Tn is, just throw in your equation of Tn there, your general term of Tn, and then solve the inequality. So for us to get Tn, well, let's put here, what question is this one? It is question 2.2.2. So obviously try and always number your questions. That will always help you before you hand in your paper to know what is what and stuff like that. Sounds like something dumb to say, but but I'm not a teacher, so I'm sure they see like times where people have just not numbered their questions and then they're just like, wow, does this child not want their marks? So yeah, this is for the teachers out there. You know, they want you to put your answers with, you know, the position number of them on your papers. So we just need to get our value for Tn first because they want us to solve this inequality, right? This inequality here is what they want us to solve. We cannot solve this inequality without Tn. So this question is basically twofold, you see. They want us to get Tn and then they want us to work out our inequality. So our Tn is nicely given technically because we have our a is just, what's our value for a? 5 over 8, right? 5 over 8. And then our r is just a half, and then this is to the power of n minus 1. Don't multiply these two. Well, yeah, don't, because of that exponent there, you see. This exponent is telling you that 2 to the power of this exponent cannot be multiplied by this value. That's mathematically incorrect. You don't want to do that. Don't do that to yourself. Nope. You're literally almost there, so don't make silly mistakes like that. They will hurt you, and you don't want to be hurt in an exam. Being hurt in an exam is not nice, you know. So let's carry on here. So getting our general term, we got it. Now we just need to solve this inequality technically first. This is saying 5 over 8 with a half here to the power of n minus 1 bigger than 5 over 8,192. Solving this inequality, the first thing is, well, technically you want to divide by 5 over 8 on both sides. And dividing by 5 over 8 on both sides, if you use your calculator, which you obviously want to do, you are going to get the 1 over 1024. You see, all we did was both sides, because these two are being multiplied by each other. You want to say this term divided by the value in front. You see, that's going to give you this number. You want to divide this value on both sides. So here you're just going to have your half to the power of n minus 1 on its own. And then at this point in time, you're almost there, you know, just hang in there. So the only thing with this question is, you may be thinking to yourself, are we going to use logs or not? What are we going to do? It's just going to be a lot of questions in your mind. So for us to answer this question, this is what we are going to do. So for this question, we're definitely going to use logs because that's, you know, easier. So what you want to do is, for this particular question, this is what you want to do. Carrying on here, we know that we have a base to the power of an exponent, and then this is smaller. No, this whole thing, where is it bigger than this number? So what you want to do for yourself is, firstly, you are going to have here, we want to isolate our exponent, right? To isolate our exponent, the one thing that you do is you isolate that exponent, you see. So let's isolate our exponent. So to do that, what you want to have there is log, and then whatever your base is, it is going to be the base of your log, which is just a half. And then this value here is going to go here, 1 and 1024. And then your value for n, which is, well, your value for your exponent is going to be here, which is just n minus 1, you see. Log your base with this value. You see where the base is, that's where your log goes. and then this value just goes where the log is, and then here you have that on the other side. If you haven't worked on logs yet, then that's fine. You will work on it soon. If you are at the end of the year, you probably did work on logs already, so this is not rocket science yet or at all. So here, if you put all this in your calculator, you're going to get that this is a 10. You see, 10 bigger than negative, 10 bigger than n minus 1. And then if the 1 goes over, this is just going to show you that your value for n needs to be smaller than 11. So the question basically said, determine the largest value of n for which this number in your sequence is a number that is bigger than 5 over 8192. So what you want to recognize is that this sequence is getting lower and lower and lower and lower and lower. So they basically want you to work out what's the last term in your sequence here that's going to be bigger than this number. So technically, for this expression to hold, our n values need to be smaller than 10. So it just means that the term in our sequence, the number of the determine the largest value of n. So it just tells us that the largest value of n in our sequence that is going to be bigger than this number is technically where n is equal to 10. And let me explain that quickly. So we know that this is basically telling us that our numbers are getting smaller and smaller and smaller and smaller and smaller. So the moment we get to the 10th number, that number is going to be bigger than this value. The moment we get to the 11th value, it is not going to, accommodate our expression anymore. So if you want for yourself, we know that if this sequence gets smaller and smaller and smaller and smaller and smaller, term number 10, if you quickly check that out in your calculator, let's see here. If you put everything in your calculator, right, and I'm using the calculator, by the way, this is technically 5 over 8 with a half there, and the whole thing. Let's put this to the power of 10 minus 1 for the 10th term, you see. That would give us, the light. This is giving us 5 over 4096. And you see 5 over 4096 is definitely bigger than this value. However, if your value for n there, where's the flash? If your value for n there was like 11, you see, let's put 11 here. You're getting the 5 over 8192. You see, 5 over 8192 is not bigger than 5 over 8192. I hope that makes sense. You see, determine the largest value of n for which this value is bigger than 5 over 8192, for which Tn is bigger than 5 over 8192. So we know that the 10th term is the last number that's going to be bigger than this value. So that's why our value for n here is just a 10. Very crazy question, very crazy question. So if you had left it as n needs to be smaller than 11, well, for this question, you should get at least 3 marks for that. I mean, this here also will just make sure you get all your marks. You see, n needs to be equal to 10. That's going to be the largest value for which this term in our sequence is bigger than this value. So that's 4 more marks. Moving on, we have some sigma here. Sigma notation. So let me know in the comments if you like sigma notation questions. Are sigma notation questions the kinds of questions that make you want to cry? Which is sad, I'm sorry. Well, this is going to help. Or are sigma questions the kinds of questions that you go, yeah, let's go. Let's get some more marks. I mean, look here, we have 4 marks here. So let's just get those 4 marks quickly, and then we will move on afterwards. So for 3.1, right, 3.1 looks a bit weird. Yeah, it kind of does. But before looking at that, let's see here. It says without using a calculator, which is okay. Determine the value of this. It's 3 marks. I wanted to whistle there. Well, technically I don't know how to whistle. Let's see. Wow, this is embarrassing. Yeah, I don't know how to whistle. Yeah, whatever. Anyways, it says here, without using a calculator, determine the value of this. So technically what's happening is this is just the number, and then this is also just the number. So we technically need to work out what is this number minus this number. Now, to do that, you want to have an idea of what your sequence actually looks like. Like, what is going on here with these two sigma notations? So the one thing with sigma notation is that this is basically just a sequence where we add up terms from the third one, right, all the way until the 10th one. You see, something like that. But I'll repeat that just now. So here we just need to firstly go and clarify what's going on when you have a sigma notation expression. So here, our first expression here, there is 10 up there with our sigma symbol. Ooh, I keep doing that. If I do stuff like that where I'm like saying something and you cannot see what I'm like talking about, it's probably because I'm not looking and seeing where this is. But anyway, so we have this value here, right? And we are subtracting sigma with 10 and y equal to 3 at the bottom, and then we have 1 over y minus 1 there. Woo, yep. So yeah, that's just kind of weird. But anyways, so with this kind of a question, right, this is all you want to take note of. This is what's happening. A question like this one is basically saying you need, no, that's jumping too far ahead. This is what sigma is. Sigma basically tells you that this is a value where you're starting off, right? You have a sequence here, basically. This is a general term for a specific sequence. It doesn't have to be a quadratic sequence or a geometric sequence or an arithmetic sequence. Nope, it can just be a random sequence. This is its general term. Down here, this is telling you that you need to add up values starting from the 10th. No, starting from the, why do I keep making these useless mistakes? Goodness. This is telling you that you need to add up values starting from the third one until the 10th one. You see, you need to take this sequence, add values starting from the third term until the 10th term, you see. So whatever this sequence is, that's what you need to do. You need to work out what this number is going to be if you add up numbers starting from the third one until the 10th one. This is what's going on here as well. You need to work out, you need to think to yourself, in this sequence, right, whatever this sequence is going to be, you need to work out terms starting from the third one until the 10th one. You need to add them up and then see what this value is. Now, because they said don't use your calculator, the first thing you do want to do is just try and give yourself an idea of what kind of a sequence this is, or what does this sequence even look like. So you see there, I forgot to put my number. Ooh, it's terrible practice. So if you think to yourself, this sequence here, if you want to map out what this sequence looks like from the third term until the 10th term, this is all you're going to do. You see where y is? You're going to throw 3 there until 10. So let's see there. That's going to be y with 3 minus 2. And then here 4 minus 2, 5 minus 2. You can already see where this is going. 6 minus 2, 1 with 7 minus 2. And then here 1 with 8 minus 2, and then 1 with 9 minus 2, and then finally the last one, 1 with 10 minus 2 at the bottom, you see. So if you look at, let's label this hashtag 1 for sequence number 1. Let's label this hashtag 2 for sequence number 2. So with these two sequences, right, we know that this, for the first one, this is what you should visualize. Now, if you simplify nicely, what you will actually see is that this is just 1 over 1, which is just the 1. And then here you technically have, well, what is this now? This is 4 minus 2. And we know that 4 minus 2 is just a 2. Why did I have to take so long to figure that out? Wow. Weird. 1 over 2. And then this is just 1 over 3, 1 over 4, let's see here, 1 over 5. And then this is like 1 over 6. And then this is like 1 over 7. And then this is like, wow, I'm still thinking about it. Can you imagine? This is just 1 over 8 and then 1 over 8, you see. So we have 1, 2, 3, 4, 5, 6, 7, 8 terms. 1, 2, 3, 4, 5, 6, 7, 8 terms. You see, because from the third one to the 10th one, it's actually 8 terms. Weird, right? It's not 7, it's not 10 minus 3. So never do stuff like that when you want to work out how many terms are actually in your sigma question. Because remember, with some sigma questions, right, you will easily have like a arithmetic sequence here. And then for you to work out the sum of those terms, for you to know how many terms you're working with, don't say the top minus the bottom only. No. For you to know how many terms you're working with, it's always the number at the top minus the number at the bottom plus 1 all the time. You see, this is proof. You see, we're working with 8 terms because 10 minus 3 is a 7 plus 1, that gives you 8. You see, that's just a rule of thumb. Don't forget that. So we at least know what sequence number 1 looks like. Sequence number 2, this is clearly telling us that it's going to have like a similar vibe going on. So sequence number 2 is basically just going to be 1 with 3 minus 1 there. And then 1 with 4 minus 1, 1 with 5 minus 1, going on and on and on and on. So this is technically 1 with 6 minus 1. Yeah. In an exam, one thing you should want, bloopers again. This is fun. With an exam, one thing you never want to do for yourself is to go in hungry or tired or sleepy or whatever. That's going to show you flames. It's going to backfire like big time. It's the worst thing that anyone can do for themselves. I know I say this a lot, and some people just don't listen to it. It's fine. It's fine. I mean, you know, everybody is their own person, so you legit never have to do what anyone tells you. It's a choice. You either choose to do it or you choose not to do it. But whichever way, never go into an exam tired or hungry or sleepy or anything. That's just a very, very bad recipe for disaster. Because look, I mean, you don't necessarily need to write all this, but you need to think of it, you know, and all that thinking is going to be necessary. If you do write it out, that's perfect. That's totally perfect. So the reason we have written this out is that's one way we're going to answer this question. They say don't use a calculator, you see? Don't use a calculator. So we need a way to figure this out nicely. So they said we should add up all these terms, and then we should subtract all these terms added up, you see? So technically what we have here is this term plus this, plus this, plus this, plus this, plus this, plus this, plus this. And then we need to subtract all these terms here, technically. Well, if you look at it nicely, what's going to happen here is, can you see you technically have 1 here, plus this, plus this, plus this, plus this, plus this, plus this. And then if you minus these values here in brackets, say you had all this laid out in one line, you would have a minus here, right? And then if you're going to work this out mathematically correct, you would multiply the negative inside your bracket, right? Meaning all these values would be negatives. So essentially, all you want to think to yourself is you have all these numbers here minus all these numbers here, you see. So all that would happen is you can literally just chop things out. You see, we have a half here, so it's going to subtract this half here. This third is going to subtract that third. You see, it's just going to be like a chopping block type of thing going on, you see, because you'll have all these numbers. Let's leave that one for now. You see, all these numbers, you're going to be subtracting all these values here. So these will cancel each other, you see, because they are in both of our sequences here. So all you will be left with is technically this 1 over 1, because it does not have something here, and this 1 over 9 here. You see, 1 over 1, which is just a 1, minus 1 over 9 in your calculator. This will obviously give you the value 8 over 9. You see, that's how you'd work this out without a calculator, because a calculator would not help you anyways. You see, that's just like, yeah, your calculator is going to do jack because there's no formula for these two, remember. So yeah, moving on. You want to move on, you want to get your marks. Yeah, don't dwell on something for too long. And you see, this is just 3 marks anyway. So remember, rule of thumb is yeah, if anything, whatever the marks that you're getting, just think of that as your minutes, you see. But then if you want to work out like an actual way to determine how many marks or how many minutes you have for like a specific question and all that. All you do is times your number of marks by 1.2. You see, any mark allocation, if you multiply it by 1.2, you will get an exact value of the minutes that you have for that question. Like here, 3, if you multiply that by 1.2, this is giving you 3.6. So you basically have 3 minutes and how many seconds? 3 minutes and 40 seconds. Or not, I don't know. 3 minutes and 40 seconds, somewhere there. That's how much time you have for this question specifically. And then for this 19 mark question, you technically had 19 times 1.2. So you technically had 22 minutes for that one. And then for this 22 mark question up here, you technically had, let's see, 22 times 1.2. That was like 26 minutes for that question. So yeah, that's just some additional information. I don't know, whichever way, that's what you want to think of it as. So with this question now, very interesting question. Well, it goes with this sketch, so that's interesting. We have here, it says, a steel pavilion at a sports ground comprises of a series of 12 steps, of which the first 3 are shown in the diagram below. Okay, so we just have a steel pavilion thingy, and we have 12 steps there, and then it says here, of which the first 3 are shown in the picture below. So it has 12 steps, but they're only showing us 3 here in this picture. Now the one thing to take note of is, you see the dimensions. We have 5 meters here. We have 3 over 2. Yeah, no, 2 over 3 here. We have 1 over 3 here. You see 1/3, 2/3, and 5 meters, which is okay, I guess. This is a 6 mark question. They said the open side, which is the shaded part on our sketch, on each side of the pavilion must be covered with the steel sheeting. So yeah, on the left hand side of your pavilion and on the right hand side of your pavilion, it should be covered with a metal sheeting. And then it says you calculate the area in meters squared of metal sheeting needed to cover both sides. Okay, for 6 marks, well, all questions at first glance look weird. They don't look fun. They look like they want to kill you. They look like they're out to get you or whatever. But this is not one of those questions. You see, this is just additional information because it goes with our sketch anyways. Well, it says here each step is 5 meters wide. Each step has a rise of 1/3 meters and has a thread of 2/3 meters as shown in the diagram. So that's fine. I don't think that's a problem. So they say we should calculate the area in meters squared of the metal sheeting needed to cover both sides. So what we need to think to ourselves is on the left hand side of our pavilion. So we technically have this side here, right? It goes all the way to 12 steps. Don't forget that this goes all the way to 12 steps. So what we technically want to think to ourselves is, with this area on the left hand side, you're obviously not going to work it out all at once because you can't. What you can do though is, let's see what's happening here. You see you technically have here, let me do this. Can you see you technically have here 1 block here? And then for the second step, you have like 2 blocks there. For the third step, you technically have 3 blocks there. So technically, if this goes all the way to the 12th step, it means that the 12th step technically has like 12 blocks there. So all we need to think to ourselves is, what is the area of this block? And then times that by 2, by 3, going on and on and on, all the way until the 12th one. You see, we just need to work with an individual block. And then think to ourselves, this area here, for this step, it's going to be double. For this step, it's going to be triple, going on and on and on. So you're obviously not going to do all that manually. Because this is a question within number patterns, you want to think of a system or a sequence that you can use to work out your area. Because you're technically going to work out the area for the left step and then just times that by 2 because it's, no, area for the left side and then just times that by 2 because you have 2 sides that will look like this. So let's jump into this question. We need a sequence for the areas of the blocks here on the sides. So what I mean is we just need to work out what is the area of this block, right? And then what is the area of this block? And then what is the area of this block? We need a sequence that can map out those areas. You see, we need a sequence that can map out things like the area of the one block, and then area of the two blocks, area of the three blocks, going all the way until the 12th one, you see. And then what we then need to do is to just add up all those values in that sequence, because it will be basically adding up the area here, the area there, all the way until the 12th step. And then as long as we have that value, we just multiply it by 2 for two sides. So I hope that did not sound like a mouthful, because we're just going to work on it step by step. So the first thing we said is we need a sequence for the areas of our shapes. So you need to ask yourself, the one block here, we have, what question is this one now? 3.2. So let's put there 3.2. So for 3.2, we have one block for the first term there. You see, that one block, it is one third high, and it is 2/3 wide. You see, that's technically what we have here. 1/3 high and then 2/3 wide. So the area of this one block is technically going to be 1/3 times 2/3. In your calculator, that would just give you 2/9, you see. So each block is 2/9. So what that means is the first block, the area is 2/9. The second blocks, the area there is just 2/9 times 2. And then for the third step, the area there is just 2/9 times 3, you see. That's like 2/9. Here it's going to be 2 times 2/9. Here it's going to be 3 times 2/9, going on and on and on and on and on. So we technically have a sequence here, because we can see that here we're just adding one block, one block, one block, all the way until the 12th block, you see. So our sequence is clearly an arithmetic sequence, because we are adding areas, you see. So what you can do for yourself, because we're formulating a sequence, is we need to know what kind of a sequence we're dealing with. We said this is technically going to be an arithmetic sequence. With this arithmetic sequence, we are seeing that this is an arithmetic sequence of our areas, remember. So we can see that our first term here is just 2/9. Our common difference here is also just 2/9, because we're adding 2/9 all the time, you see. 2/9 is also our difference. Why did I put B there? Wow, very weird. B, not D. And remember, in an exam again, you don't have TPEC, so you try to finesse whatever you have to finesse. And then we said you don't get marks for neatness anyway, so do what you gotta do. I'm not saying be unneat and all that. Nope. I'm just trying to say, whoa. I'm just trying to say that, yeah, sometimes you just gotta do what you gotta do. So we say here our value for D is also just 2/9, because you see we are working with a sequence of areas, you see. The area here is 2/9, the area here you add another 2/9, the area here you keep adding 2/9 all the time. So we have A, we have D, and then we said we need to add up all the areas until the 12th term. So with our arithmetic sequence, we're working with 12 terms, you see. So we need the sum of all the 12 areas. So that means we need to use our SN formula for an arithmetic sequence. So remember, your formulas, don't cram them. You don't have to. There's zero, absolutely nothing you're going to get from cramming them. What I mean is, if they come natural to you, or if you understand them, or if you know them by head already, that's perfect. That's perfectly fine. But then, whoops, I actually ran out of film there, but I'm back now. So as we were saying, for SN, our SN formula, you don't want to cram it, right? You just want to, yeah, man, I mean, your formula sheet is there, so always just double check. So we're saying Tn n over 2 with an open bracket, and then the rest there we know it's going to be 2a plus n minus 1 with d there. And we said here our value for a is just 2/9, our value for d is also 2/9, and our value for n is just 12. You see, we want to work out the sum of all the 12 areas. and then multiply that by 2, because you see we are dealing with two sides. So let's see here. In our SN formula, n is technically 12 over 2, a is 2 over 9, and then n is 12 minus 1, and the whole thing here 2 over 9. And you see here I'm putting brackets because this part is very important. You may have noticed that obviously there are cases where if you don't use your, what do you call it, if you don't use what am I trying to say? Well, all I'm trying to say is always remember your brackets. You see, brackets are very important. They are one of those things that will make or break you. So here you want to put all this in your calculator exactly the way it looks here. So if you put all this in your calculator, right, you could maybe even put this big bracket first into your calculator. That will like give you 6 over 3, oh no, 6 and 2 over 3 here. And then this whole value in your calculator, that should give you 11 over 3. And then because these are both, with a 3 as the denominator, this will just give you 13 over 3. And then in your calculator, we know that this is just going to give you 26. But the safest way is to just throw all this in your calculator, and it's going to pop out 26 there. Now, the only issue is you want to remember that we said this 26 here, right? We need to take into consideration how it is 26 meters squared. So the area for both open sides is just going to be 26 times 2, which is clearly just going to give you 52 meters squared. You see, because all we had to do was to work out what do all the areas on the one side add up to if we are dealing with like 12 steps, you see. So we said A was just 2 over 9, our D was also just 2 over 9, and then we are working with the first 12 terms. So this is giving us the area of the one side. And then if you multiply that by 2, we know that the area of both open sides will just give you 26 times 2 there, which is just 52. So moving on to the next question. Now my assumption is you probably skipped over to the functions part, because this is where the bulk of the problems start, or where the bulk of the marks also come from. So with this functions question in our grade 12 paper 1, or rather grade 12 maths paper 1 November 2019 memo, we have here a functions question, right? It says below are the graphs of f of x, which is a parabola there, but the equation is not given. And then we also have an equation of a hyperbola there. It is also just an open equation. So we are given key points here. They said f has a turning point where C is, and it passes through your x-axis at 1 coordinate 0, which is there, so that's fine, good information. D is the y-intercept of our hyperbola and our parabola. So you see here D is the y-intercept of both f and g. The graphs of f and g also intersect each other at E and J. You see E is there, J is there, so they meet each other in 1, 2, 3 places. Interesting. Then it says the vertical asymptote, which is your asymptote from top to bottom. Your vertical asymptote of G, they say it here, the vertical asymptote of G passes through the x-intercept of F. So you see the vertical asymptote there is a positive 1. So the equation of this vertical asymptote, we know it is just x is equal to positive 1, because the equation of any asymptote is all dependent on where it cuts your axis. You see, if it's a asymptote that cuts the x-axis, then you just need to look at the value that it cuts. So that's the equation of our asymptote if we ever need it. So okay, that's fine, information is given. Let's jump into the questions. So yeah, I'd never jump into the questions before reading this. It is the most I was about to say the most useless thing you can do, but I think that sounds a bit weird. Well, jumping into your questions before looking at this, that's like very deadly. Deadly. Goodness, I'm trying to think of the words. Well, it's just a bad idea. Yeah, don't do it. So we need here to get a value for P. Oh, why am I shaking so much? We need here to get a value for P for our graph of G. So, and it's a 1 mark question. You see why they're making it a 1 mark question, because where P is, it represents the Y value of our vertical opposite. Whoa, our vertical asymptote, but the opposite of it. Yeah, you see, this is what happens when you have videos where you're going through entire past papers. You really cannot edit them too much. There'll be bloopers everywhere. So what we said was, we know that this value of P, right, will always be giving us an idea of our asymptote, as in our vertical asymptote. So because our vertical asymptote passes positive 1, it means that the value of P there has to be a negative 1, you see, because you always take the opposite of what is actually in your Cartesian plane. So for 1 mark, right, with 4.1, all we need to say there is that P is equal to negative 1. The reason is, in our equation, it's going to be a negative 1. On our Cartesian plane, the asymptote is going to be passing a positive 1. You see, you always work with the opposites. So B, or rather 4.2, says here we should show that A is equal to 3, and we should show that B is equal to 2. So they are essentially asking us to get our equation of f of x and our equation of g of x. So that's fine. Our equation of f of x, clearly we said that's just a parabola. We can see it. I mean, the equation is of a parabola. Yeah, it's a parabola. If it looks like it, if it smells like it, it's definitely it. So with this parabola, for us to get a value for b, it's going to be very simple, because all we need is a point that the graph passes through. We need a point that the graph passes through, so that we can throw that where x is, and we can throw that where y is. The only problem is we have multiple points that are given. You see, like D. D is technically given. The reason is, can you see where D is? D is the y-intercept of our parabola. Now, we know that this value always gives us the y-intercept of our parabola. So we have a coordinate given here, right, which is technically just 0 coordinate negative 3. However, this cannot help us, you see, because if you throw 0 where x is, you would have 0 times b here, so your b will be gone and you won't be able to work it out. So this value for D here cannot help us. This is actually just an arrow, but then here we have our letter D. So D won't help us. If you look at this point though, can you see here they told us that our vertical asymptote of G passes through the x-intercept of f. So because this is an x-intercept of f, it means that this point here has the coordinate 1, coordinate 0. And then this is a point that our parabola passes through. And this point can help us work out our value for b here. Because in our equation for f, all we need to do is, where y is, we're just going to throw a 0 there. Where x is, we know that's just a 1. And then we can work out b here without removing b. So here we know that this is just 1 plus b minus 3 equal to 0. And then this is just, let's see here. What is 1 minus 3? 1 minus 3, that's like, I was about to reach for my calculator. Well, yeah, 1 minus 3 is actually negative 2. And you saw I was kind of stalling there because my brain was like, wait a minute, what is 1 minus 3? Kind of forgot that. But 1 minus 3 is just negative 2. And then b is giving us a positive 2, which is, you see, what they want us to prove. So that's perfect. So you keep moving on. The next one is getting a value for a. And you see, we're going to use the same idea. The only thing is, with our graph of G, remember, we already worked out our value for P. We say that P has to be a negative 1. And the reason for that was our vertical asymptote over there. So, yeah, G, if you're going to work out a value for A here, you do the same thing. Just look for a coordinate that the graph passes through. But then don't use a y-intercept, because that's not going to help you. You see, y-intercepts mean that where x is, you would throw a 0 there. But, for this question, it actually would be fine. Perfect, actually. D is a value that our graph of G passes through. Now, with D, what you want to take note of is that, can you see x is a 0 and y is a negative 3? So if you were to put a 0 here, it's fine. A would not be affected. So that's perfect. Let's do that. A here, 0 minus 1. And then here where g of x is, you are just going to throw in a negative 3 there. And then this is just a over negative 1, which is the same as negative a. And then if you divide by negative on both sides, you are getting the... Wow, why did I put this there? Just gave myself trouble. A here is a positive 3, which is what they want you to show. So questions that want you to show something, those are usually the most comfortable ones because, I mean, you don't have to guess whether or not your answer was correct or anything. It is just, you know, there for you to see. So, oh yeah, we forgot to tick. yeah, my laugh. Wow. Tick there, marks, tick there, marks. And then here we now have to calculate coordinates of C. So C is the turning point of our parabola. So the good news is in grade 12, if you are going to work out where a graph turns, you can actually use differentiation, you know, because differentiation is fun, I guess. If you don't like differentiation, just let me know in the comments. If you like it, also let me know in the comments if you're a fan of differentiation, because I'm a huge fan. Differentiation is okay, you know, it's where the marks come from. So getting the coordinates of C, because it's a turning point, we are just going to use our graph of f. We're going to differentiate it and equate to 0. That's going to give us the x value of the turning point. And then after getting the x value of the turning point, we can easily throw it into our main equation, which we have a full equation for now. And then we will be able to get the y value of our point C there. So we're just going to differentiate and equate to 0. So the first thing we can lay out for 4.3 is that with 4.3 we have f of x here, which is equal to x squared plus 2x minus 3. And then if we differentiate that, this is going to be 2x plus 2. You see, we've differentiated it, and you're going to make this expression equal to 0. This is going to give you negative 2 there with 2x here. Divide by 2 on both sides. This is going to show you that your x value is just a negative 1. So that's perfect. A negative 1 is your value for x there, which kind of makes sense, you see, because y, your value for c is on the left side of your Cartesian plane. So you've gotten your x value, which is a negative 1. Now what you do is, in your original graph, where x is, you want to throw there a negative 1, you see. So if you throw a negative 1 in your original equation, you're getting the 1 minus 2 minus 3, which is just 1 minus 5, which is just negative 4. And then if you left it like this, this is a full coordinate, because this is showing you that x is negative 1, y is a negative 4. So you can say here, therefore, C is just going to be negative 1 and negative 4. You see, I was about to make one of those very sad mistakes where you like, what do you call it? Yeah, where you basically just are done, and then something happens, you know, some bird somewhere in some country makes a certain turn, and then that causes you to like miss a sign here. Yeah, I'm just off ramping here. Well, all I'm trying to say is just make sure that your signs, just always double check them. Don't lose marks because of things like signs. That's just the worst, you know. And you see, the theme of this is don't forget your signs. I think I've said that so many times now. So with 4.4, it's another simple question. Let's get ourselves that mark tick. So with 4.4, they said here, write down the range of f. Now the thing is, you see, f is a parabola. Whatever graph you're working with, range just means where do you see the graph from top to bottom. You know, we have a graph here. Where do you see it from top to bottom? That's what your range is asking you. Now your range, you always answer it in terms of y, you see, because I mean, if you're looking from top to bottom, you're looking along your y-axis. That's what you should remember. Range is looking along your y-axis. If you look from top to bottom, we see our graph from this turning point going up, you see. From this turning point going up, that's where we see our graph. And this turning point at this specific y value, our graph does touch there. So we need to include it. So our range for 4.4 you basically need to say that we see the graph where our y values are bigger or equal to -4. This is where we see the graph. That's what range is asking you. Range will be asking you, where do you see the graph? That's it. So we have told them where we see the graph. If you wanted, you could have said that y is an element of -4 all the way until infinity. Now the thing with infinity is it is never included, so you always put like a round bracket there, because I mean, who knows where infinity ends anyways. If you find out, let me know, because I want to know. But anyways, so with 4.5 now, we know that with this question, right, that we just worked out, they were asking us to get the range. We got range. Now with 4.5, let's see what we have here for 4.5 in this functions question. They said determine the equation of the line. Let me read this slowly. You see what I did there? I noticed that I was just about to read for the sake of reading, without like reading for the sake of understanding first, or something like that. So here it says determine the equation of the line through C that makes an angle of 45 degrees with the positive axis. Write your answer in the form y is equal to something. I should have just printed out a nice paper, because now we have to flip over and stuff. But anyways, yeah, that's the most, yeah, that just sucks so bad, because it's like, why do you have to be so difficult? But let me finesse this quickly. There we go. That looks so much better, because we have our question and we have our picture. So, you know, the brain is happy now. Anyway, so with this question, right, they said here, determine the equation of the line through C that makes an angle of 45 degrees with the positive x-axis. Write your answer in the form y is equal to something. And this is just a 3-mark question. You see, 3 marks that we're about to get. So all you want to do is visualize this scenario. You see, we are talking about a straight line graph that makes an angle of 45 degrees with the positive axis, and it passes through C. So, I mean, you technically just want to think of a line that goes from C here, and then, you know, it's a straight line, obviously. For the next videos, I should get me some highlighters, you know, and stuff like that, so that things are, you know, colorful and all that, because I mean, this is just too black. It's just too dark. It's just too, yeah, you know, it's not, yeah, it's not colorful. But let's see if this orange pen is going to help. Nope. It's not gonna help. Should have just gotten some highlighters, but it's too late for that. I hope you can see this straight line that we're talking about. So this straight line here, they said it is a straight line that forms an angle of 45 degrees with the positive axis. So what that means is, you see, if it forms a 45 degree with the positive x-axis, remember, you have two portions here of your x-axis. Your x-axis has a positive side and your x-axis has a negative side, because remember, this straight line could have easily been going that way, you see. But then if it was going that way and this angle was 45 degrees, then it would have been 45 degrees with the negative x-axis. See, that's why this portion is important. 45 degrees with the positive x-axis. So you have to think of where the positive x-axis is, and then that's where your 45 degree angle is. So that 45 degree angle is like somewhere there. Okay, so this angle here is basically just 45, which is fine. So that being given, they said we should get the equation of this straight line. Now, anytime you need to get an equation of any straight line, regardless of the question, it will never matter. But as long as you need to get an equation of a straight line, always write out what the standard form of a straight line looks like first. So y is equal to mx plus c. That's what you want to write out first, because the moment you write this out, you will be reminded that, wait a minute, all I need is two things. I just need a gradient and I just need a y-intercept. So let's do that. So to get your gradient, the one thing that we have been given here is the angle of inclination, or an angle here. You mean whatever you want to refer to it as. that angle there is just 45 degrees. So this angle being 45 degrees, we know that to get gradient using this angle, we can basically use this formula. M is equal to tan with an angle here. So let's just put theta there because that's on our formula sheet anyways. So here what we can do is where theta is, we can just drop the 45. Now in your calculator, here you don't need to do shift anything. I mean, look, it's just 1045. So in your calculator, just throw in the 1045. I know that was like a blunt thing to say, but oh well, I said it. I can't take it back. I'm sorry. So gradient here is a positive 1. So it just means here y is a positive 1x and then plus c. And luckily to get c, all you need is a coordinate that the graph is going to pass through. And we know that our straight line here passes through the coordinate c there. So, I mean, we have the value of the coordinates of c, right? We have the values of the x value and the y value of c. So all you want to do is in your equation here where y is, we know that's just going to be -4, x is a -1. Our c value here is going to be -4 plus 1, which is clearly just going to be -3. So here our final answer is just going to be y is equal to x minus 3, which kind of makes sense because I mean this straight line here would need to pass our x-axis somewhere there, you see. And then, well, technically this is not to scale. Well, this is just saying our straight line should pass through C and D and then go, you see. But when I drew this, we didn't know, so I just drew a random line. But then this is clearly telling us that the y value of our y-intercept is just going to be a -3. So you see here, this was quick, straightforward, to the point. You have 3 more marks. You, if you want to have like a mini victory dance, do that while you're seated. Don't make too much movement or whatever. But yeah, just whatever it takes for you to stay happy in an exam will do. So let's see here. In the straight line. Oh, no, not in the is. This is not in. Yo. Yeah, ne? Is the straight line determined in 4.5 a tangent to the derivative of f? Explain your answer. Oh, let's do that again. Is the straight line determined in 4.5 a tangent to the derivative of f? Yeah? Why would it be a derivative? Why would it be a tangent to the derivative of f? Yeah, I think that's just my pen mark there. Let me look closely. Nope. Whoa, where was I looking? There. You see, this question, you can see even how I'm reacting. You see, it's a 2-mark question, right? But then it clearly does not look very normal. I mean, like, whoa. Yeah. That doesn't make any sense. So with this question, right, here they're technically asking us, is the straight line determined in 4.5 a tangent to f? Oh yeah, a tangent to f, not the derivative of f. This is asking you, is it a tangent to f of x, you see, because the derivative of f is a straight line. You see, straight lines don't have tangents because straight lines are straight lines anyway. So there's no point where, you know, a graph will touch a straight line once. Well, yeah, this is creepy or weird. But what I'm trying to say is this question is basically asking us, is the straight line determined in 4.5 a tangent to the graph of f? Explain your answer. So this straight line here, they're asking, is it a tangent to the graph of f? Well, the blunt answer there is a point blank no. I mean, it's a 2-mark question and it's 2 free marks. Because firstly, C is the turning point of our graph, you see. And we know that where a tangent meets a graph, their gradients should be the same. So the only problem is our straight line has a gradient of +1, you see. So if this straight line is going to be a tangent to our sketch and it passes through C, this point here, the gradient of our tangent here, which is a 1, and the gradient of our curve should also be a 1 at this point. But because the gradient of our curve is a 0 here, and the gradient of our tangent is a positive 1 here at the point that they meet, it means that this cannot be a tangent, because for this line to be a tangent, they have to meet at a point where their gradients are equal to each other. You see, that's the one big thing. A tangent to a curve is a line that meets the curve at a point where their gradients are equal to each other. So because this is a turning point, it means the gradient of the curve is a 0. And our tangent, we can see that its gradient throughout is a positive 1. You see, its gradient throughout is a positive 1. So the point where they meet does not have the same gradient. So for 4.6, and take note of how 4.6 is just a 2-mark question. This is telling you that don't blow your brains out. No, don't go kaboom. It's not necessary. 4.6, all you're going to say is no. That's going to give you 1 mark. And your reason is the straight line. Let's put here the straight line. And you see here in my handwriting. Well, I like it though. It helps me write fast. It says here, no, the straight line does not have the same gradient as the curve at point C. The reason we're using point C as our main focus is because point C is a point where our straight line is touching our graph. So at the point where they meet their gradients, they're not the same. So nope, it's a no from me. You're not going to Vegas. Sorry. 4.7 says the function k of x. No, h of x. So it says here the function h of x. So you may be asking yourself, we are 3 words into the question and they're talking about h of x. But then our entire question, there's no h of x anywhere. We haven't seen any h of x. You see? Nope. If you saw h of x anywhere, yeah, you're seeing things. There's no h of x here anyway. However, when they refer to graphs that are not in our question, that's fine. All they're trying to say is you need to imagine things. Well, yeah. So they say it here, the function h of x is equal to f m minus x plus q. Wow. Has one x-intercept. Has one x-intercept at x is equal to 0. Determine the values of m and q. Yeah, that's a botched question. Why? That's the one thing with maths and school that's just weird. Like, what the function h of x is equal to that, has one x-intercept, and then they say they where x is equal to 0, determine the what you call the values of m and q. Yeah, that's yeah. Yeah, that's just weird. That's just proper weird. But anyways, we need to know how to answer these kinds of questions, right? So if you're going to answer questions like this in an exam, remember, don't tackle questions like this if they are just questions that upset you in an exam. If you, let's say, bumped into this question and then something in your stomach just, shrunk, or something in your chest just, jumped up and said, oh no, my marks, they're about to tank, then it just means that's a sign for you to move on. It's a sign for you to put your energy into other questions that may get you more marks. And then when you're completely done, you're more relaxed, you've gotten all the marks that you could possibly get, then you would come back to questions like this if they are the kinds of questions you don't like. However, with this grade 12 maths paper 1 November 2019 memo, we are going to go through it, you see, because that's what this channel is all about. It's all about going through past papers from start to finish with a weird narrator showing you like all the stuff that you need to do. And yeah, so let's get it. With 4.7, just take things slow. Don't panic. They're just saying here h of x is a specific function, right? And that specific function is just the graph of f if you throw in m minus 1 where x is, no, if you throw in m minus x where x is, and then you plus q to that. So what I mean is, right, here you see your question, before we look at the rest, they had the h of x is equal to f with m minus x and then plus q. Before you even worry about what the question is asking you, they say that this function has only one x-intercept at x is equal to 0. Determine the values of m and q. Okay, that's interesting. So reading the question again, it gets easier the more you read it, because what you need to visualize first here is we have a function here. This function is like a hybrid of f, if I can put it that way. The reason is, if you remember from our previous question, we worked out f, right? We worked out the full equation of f. And we got the x squared. Our b value, if you recall, was a positive 2. So it's f of x is equal to 2x and then minus 3, like that, you see. So we have f of x here. And then they said we should work with this function and get our value for m and q. The one thing they did tell us is that this has one x-intercept, which is 0 where x is, you see. It has one x-intercept at x is equal to 0. So I mean, a graph that has an x-intercept where x is equal to 0, it means that whatever this graph is, right, it passes our x-axis where x is a 0. So that's fine. So anyways, where I was trying to go with this is h of x is just an equation that looks like this. All they have said is, you see this whole thing here, what it means is, in your equation of f, you see in your equation of f, where x is, you should throw this whole thing in there, you see. Meaning in our equation here, you see where x is, we have x there, we have x there. So this is telling us in this slot and in this slot, we need to throw in this whole thing, which is just going to be m minus x, the whole thing squared, plus 2, and then m minus x minus 3. You see, that's what this portion here has told us. But then this whole thing, we should plus a q there. Q is just a constant technically, because q is just a number. I mean, yeah, q is just q. So this is what h of x looks like. It is just this whole thing here squared plus 2 here with this value minus 3 plus q. You see, because you see where x is, we have this here squared. You see where x is, we have here with the 2. We see where 3 is, that's just there, you see. And then the plus q is just the plus q there, you see. So that's what this statement has told us. Now they said with this equation given, it says here the function this has only one x-intercept at x is equal to 0. So this is what you want to take note of. Remember how if you need to work out an x-intercept, you make y a 0. If you need to work out a y-intercept, you make x a 0. So let me repeat that. Remember, if you need to get an x-intercept, if you had to find an x-intercept, you would have made y is equal to 0 in whatever equation that you have. So here they said this function has one x-intercept at x is 0. So technically they've given us a coordinate that this function is going to pass through at some point. You see, because the x-intercept, you would have made y a 0. So you automatically know that the y value there is a 0, because at an x-intercept, the y value there, you make it a 0. You see, so in your equation, you made your y a 0, and then you found out that your x value is just a 0 as well. So that's one big thing that you want to take away from this question. You see, I'm even going to read it again. They said it has one x-intercept at x is equal to 0. So an x-intercept, the y value there is automatically a 0. So we have a coordinate that this graph passes through. Let's just take note of that here. We have a coordinate here. Whenever we'll need it, we are going to go to it and ask for help, because yeah, you see this question, it's out of 4, which is okay, but again, it's not a normal question. And we said in an exam, if this kind of a question kind of upsets you and all that, just move on, you know, just go to something else and yeah, work on that. So at this point in time, we would, well, technically we just want to simplify as best as we can. Let's just simplify our equation of h and then see what we end up with, and then just take it from there, you see. So yeah, one step at a time is the name of the game. So with what we have here, we know this is just two brackets, m minus x, and then also m minus x. And then here we have plus 2 here with m minus x minus 3 plus q. And then these two, you need to multiply them out. This is just m squared minus x, m squared, and then minus xm, and then minus xm, and then plus x squared. And then here this is plus 2m minus 2x minus 3 plus q. And then let's see what we have here. If we just simplify, right, you see here m squared does not have a friend. Wow, letters are friends now. No, m squared does not have a common factor. So this is m squared, and then this is negative 2xm, and then this is just x squared. It also does not have a like term, so it's alone. Oopsie. And then here, 2m does not have a like term. Wow, this is very interesting. And then here, negative 2x also does not have a like term. Well, technically this, let's just rewrite this for now, and then I will just talk about the rest, because yeah, it's about to get okay. So with an expression like this, we don't want to forget that this is in terms of, this is an equation of h. Now, an equation of h means that we need to focus on x, you see. So let's put this in descending powers of x. What I mean is, what you're going to note is that you see there's x squared here. So this x squared has to be written out first, because, I mean, that's how maths is. Whoever made the rules, well, fine, or using your rules. So you have to put x squared first. And then you need to ask yourself, what else has x? Can you see here, this here has x? And then can you see here, this also has x to the power of 1. You see, this has x to the power of 1, this has x to the power of 1. Now this here, let me write it as negative 2m with x there, you see, because the negative 2m, this is acting as the coefficient of x. And then here you have a negative 2x. So you see, we're now writing it in descending powers of x. Something with x squared, something with x alone, and then everything else does not have x, right? So let's put here, that's going to be m squared, and this 2m, this negative 3, and this q there. So that's going to be m squared here with 2m here with negative 3 here with a q there. So this is h of x so far. So you may be asking yourself, it's a 4-mark question. Why in the world are we still on this 4-mark question, when technically for a 4-mark question you only have how many minutes? 5 minutes. So that's another issue, right, with questions like these. Even if they don't make you go, oh snap, what's going on? These are the kinds of questions, I mean, if you sense that they're going to take you longer than what you may anticipate, trust me, just try and move on. And then move on, but don't forget that you have stuff left behind. So when you move on, just quickly finish so that you have that time at the end to come back to your questions. You see, it's all about having time at the end to come back to whatever it is that you would have left out. So from here, you may be thinking to yourself, okay, fine, we have a coordinate that this graph is going to pass through. Why don't we just throw that coordinate into this equation and see where that takes us? Well, that does sound like a good idea. However, here we say this is technically just a parabola. It's a weird parabola because let's put this in standard form. This is going to be x squared. And then here, this is technically going to be, let me put here negative 2m with a negative 2 there with the x here. You see, so that we can clearly see that our value for b is this thing here, negative 2m minus 2. That's your value for b. And remember, this we are considering it your value for b because you see here, these two both have x, you see. So this tells us that we have like terms here. They both have x, so let's put the x there. And you see I'm deliberately putting the x on the right side, whereas we usually put it in front. You see, this is to show that it doesn't matter. If you had the x here or if you have it here, same thing. So here this is clearly showing us that this is our value for b. And then here we can see that this whole thing here plus, let's put the whole thing here, m squared plus 2m minus 3 plus q. This whole thing here is representing c. So you see here our a value is just a 1. Our b value is just negative 2m minus 2. Our c value, it is just m squared plus 2m minus 3 plus q. So yeah, this question is definitely popping. It's like, yeah, it's flames everywhere. But anyways, this is what we have so far, right? A, B, and C. Now, with our question, they said that this function only has one x-intercept. Anytime you see that a function has one x-intercept, it just technically means that this, whatever this parabola is, you see, well, technically this is showing us that this is a positive parabola. Whatever this parabola is, it turns at your x-axis. You see, where your x-axis is, because it only has one x-intercept, it means that your parabola is going to tend there. So if we're going to work out values for m and values for q, you would want to think outside the box a little bit for a question like this one. The reason is, you see, we need to work out two values. We need to work out a value for m and a value for q. These are two variables. So why not just work them out simultaneously? What I mean is, have two equations which you can use two sets of information in, and then just work out m and q. You see, that's like one rule of thumb with questions that ask you to solve multiple variables. If you have multiple variables and you see that you're still stuck with one equation, yeah, you're okay, but then get another one. You see, we already have one equation here. And we said with this one equation, we already know a coordinate that the graph passes through. So let's use that piece of information first. Let's use that one coordinate that we have for our graph of h. We know that where y is a 0, our value for x is also a 0. So we would throw a 0 there. This is just 0 squared. And then technically, if you threw a 0 there, it's just 0 times this whole thing, right? Which is just 0. And then here, if you throw there's no x anyway here. So you would just be left with m squared plus 2m minus 3 plus q. And then here, just solve. Let's isolate q. It looks like q is the easiest one to isolate here. So you are going to have here negative m squared minus 2m plus 3 is equal to q. And you can label this equation number 1. You see, you have one equation that is q and m. You're safe. Ka-ching! So you need another equation. So we said, thinking outside the box, we said this is your piece of information here. You see, one x-intercept. And we said this is a parabola, a positive parabola. Now, if your parabola has one x-intercept, it means that your parabola turns at your x-axis. We have a turning point here. Remember, we have a turning point. Let me write this out. Turning point. You see, a turning point in your math is something very special because you know what happens at a turning point. Remember, at a turning point, you know that the gradient is equal to 0. Always. You see, so yeah, that's the thing with this question. Yeah, wow. Just what I wanted was to write always nicely, but look, well, anyways, you see here, they told us that our graph turns at x is equal to 0. They told us by telling us that it has one x-intercept. You see, a parabola, which is what this is, a parabola with one x-intercept means that your parabola turns at that x-intercept. Now we know that this x-intercept is equal to 0. And we also know that because it is a turning point, the gradient there is a 0. You see, there are so many zeros in this question. But figuring all this out means that the last thing you're going to get in this question paper is a 0. You might just get 2 zeros at the end of your of your mark, as in 100%. Well, I mean, people that get 100% for their maths papers, yeah. Y'all are just machines, eh? Like, goodness. But anyway, so that's where our second equation is going to come from. We need a gradient equation. Now, yeah, this is where you may be thinking, oh my goodness, what is about to happen here? Are we literally about to differentiate this whole equation here? Well, the blunt answer I can give you is yes. We are about to differentiate this equation so that we can get a gradient equation and use that gradient equation to get, you know, our values for M and Q. So you may be freaking out, but the fact of the matter is getting the gradient equation of this is actually going to be simple, because firstly, this holds away, and secondly, can you see how here we have, what do we have here? We technically have a value for B here explicitly. We have a value for A here. So this is fine. Don't worry about it. Differentiating this is going to be the easiest thing for this question. So differentiating this, you want to put your symbol for H like that. And then here it's technically 2 times the value in front, which is just 2x. And then here you technically have 1, right? 1 multiplied by your value for B, which is just your value for B. Let's put the whole thing there. And then you would remove 1 from your exponent. You see, 1 minus 1, so the x would fall away. And then this, not fall away, x would be to the power of 0, which is just a 1, so we don't have to write it. This whole thing here is a constant. So if you differentiate a constant, it just falls away. So this is your differentiated equation. You see, very nice. Your differentiated equation has, luckily, just M. Why do I keep laughing? Goodness. Yo, wow. So this is your differentiated equation. And you know that this differentiated equation, you know that your gradient is this symbol here, right? We know that our gradient is a 0, where our x value is also a 0. You see, so this is our gradient equation. We have gradient as 0, and we also know that the x value at that point where our gradient is a 0 is a 0. You see, so many zeros in this question. I hope the zeros are not confusing you. In the comments, let me know, or just give me a, just let me know, just say anything if these zeros or if this explanation for this question makes sense. You know, I would really appreciate that. Just give me an indication that you're working on 4.7 now, and all we have said here makes sense, because yeah, I feel like it makes sense. Yeah, you know, I mean, yeah, I feel like what I've said makes sense, but just let me know. So here we say gradient is a 0 and the x value is also a 0 in this gradient equation. So you see the negative 2m, we're just going to take it over. This is going to give us, let's see here, positive 2m with a negative 2 there. And then if you divide by positive 2 on both sides, this is going to be m is equal to a negative 1. So at this point in time, we're getting that our m value is a negative 1, which is great news. You see, so our second equation is perfect. M, we got it as a negative 1. So all it means is in our first equation, right, where m is, we are just going to throw in a negative 1 there. So that's going to give us negative 1, where m is, with a negative there. This is squared, minus 2m. M here is negative 1. You see, where m is, you throw a negative 1 there. Where m is, you throw a negative 1 there. And then where 3 is, you basically just have a positive 3 there. And then this is equal to q. You see, much easier, this question. And you would need to think of all this in 4 minutes. So all it means is your question, all you needed to do was to remember that this is just a function. So map it out, simplify it as best as you can. And then when things start to look funny, just remember how this equation is in terms of x anyways. So map out things with x as the, you know, the boss. So this is just a parabola, and we said all that we said, and here we are now with our value for q. Here, our value for q, remember, you want to throw all these values into your calculator very nicely, because I mean, you did all this work, like all this work. The one thing that could mess things up for you is a sign that is, you know, just weird in your calculator or whatever. So put all this in your calculator and you will see that your value for Q here is just going to be a positive 5. You see, much lovely. This question was literally all bark and no sting. Like literally as I was going through it like now, because like legit, I kid you not, I am looking at this question for the first time. And as I'm recording this, I'm legit figuring it out as well with you. So high five. Yeah, so that was weird. So we have M here and we have Q there, which is what they wanted. So you give them what they want. You take note of your 4 marks that you now have. You know, subconsciously scream at the top of your lungs because you have more marks now. And you move on, you know, you just keep chugging, you know, not chugging, oh gosh, no, you just keep going. So 2, question 5, this is where we are now, another functions question in this 2019 November grade 12 mathematics memo. Whew, yeah, it says here, sketched below is the graph of f of x. It is clearly an exponential graph. They say it here, f of x is equal to k to the power of x, where k is a value that is bigger than 0. Okay, that's nice. And then here they said the point 4 coordinate 16 lies on f. Okay. So this question seems to be friendly. You see, they just gave us a equation of an exponential graph that is incomplete. They just told us that k is a number that is bigger than 0. Okay, that's fine. So they're just telling us that k is a positive number. Okay, that's okay. So 5.1 for 2 marks only, which are very important. You see, 2 marks, this is the difference between your distinction and the 79%. So choose what you want. So here it says determine the values of k. So we can already see that this is just easy 2 marks. You get them, you just make sure that you are as careful as possible with this kind of a question, because remember we said it's always the easy questions that are going to like steal marks, because usually when you get your memo back, I mean your question paper back, you'll be like, oh my gosh, how did I lose this question? How did I lose marks here? Because it was so simple, but I made a silly mistake. So yeah, don't do that, especially for functions, you see, because if you make a mistake up here, it's just gonna, you know, have like a snowball effect. So yeah, you don't want that. But you know, that's not to scare anyone, because I mean, this is just a question paper. You are an entire human being. I mean, you know, you've got yeah, you've got something more, yeah, valuable than just a piece of paper. Yeah, what is that? Goodness. So we need to get a value for k here. In our equation of f of x, we can just throw in one coordinate that the graph passes through. So where f of x is, where y is, we know that's just 16. And then we have k here. Our value for x, that's just a 4. And then here, you want to solve for k. Now solving for k, remember you're going to put here a square root symbol with a 4, a square root symbol with a 4. And then I'm glad we're looking at this question, because there is something very important that we need to take note of. This answer here, you have to put plus or minus with this square root symbol with a 4 there. The reason is, anytime you see that you put this with a value here, as long as this value is an even number, let's put here even number. As long as this tiny value is an even number, you have to put plus or minus there. You see, if this was an odd number, then you don't have to put plus or minus. See, as long as this is an even number, you have to put the plus and the minus there. You see, that's a side note, because here this is telling us that our value for k in your calculator, let's see here, if you put this whole thingy into your calculator, you are obviously seeing that your value for k needs to be plus or minus negative 4. You see, k needs to be plus or minus plus minus negative 2. However, k cannot be equal to negative 2 because they told us k is a positive number. You see, that's why that portion of information was nice. I sounded sarcastic, but they were actually trying to look out for us and saying that you're going to end up with two answers, pick the positive one because that's what k is. K is a positive number. The reason is this is technically telling you that a number k to the power 4, if you had put like negative 2 to the power 4, negative 2 to the power 4 is still just going to give you 16, you see. However, they want us to be working with the positive version of what k is. So that's just a 2, so you get your marks and you move on. And 5.2 now says the graph of g is obtained by reflecting, the graph of g is, why am I shaking so much? Goodness, chill. It says here the graph of h is obtained by reflecting graph f about the line y is equal to x. Determine the equation of g in the form y for 2 marks. Forgot to tick that off. Okay, well, this is a nice question as well, because you see, with your papers, remember, things will be evened out. You know, there are some questions that are going to make you go, oh no, what is this? And then there are some that are just going to make you go, oh, nice, that's a very nice question. Thank you very much, because I'm about to get 2 marks for this now. So with those kinds of questions, you get your 2 marks and you move on. You see, this is where you bank some time as well, because they are quick and straightforward. Now, you see the keywords here is reflecting, and then y is equal to x. You see, that's point blank. You can think of it. What do you think? What are you thinking? Inverse, right? Inverse. Wow, I just did that thing from Teletubbies. You know, like with Teletubbies, they'll ask the people that are watching questions and then they pause. Oh lol, I just legit did that because I was like reflecting and then y is equal to x. What is it making you think of? And then I paused, but oh wow. Inverse, that's what we should be thinking of. We should be thinking of inverse. G is the inverse of f because G is obtained by reflecting f about the line y is equal to x. Now the line y is equal to x is this line here. So I'm making it dotted. This is the line y is equal to x, you see. Now your graph of g is technically going to be here. Oh wow, that's a very nice graph of g. So if we ever need to sketch it, well, let's forget about that for now. This is what g will look like, because that's how inverse works, you see. And with an exponential graph, this is definitely what g is going to look like. They just want us to get the equation of g, and we say g is just the inverse of f. So getting the inverse of f, you need to start off with f, obviously, which is just 2 to the power of x. Getting the inverse here, you need to make this a y. And then you can just write this here to show that you're about to perform inverse. X becomes y, and then y becomes x. This is, wow. Yeah. No TPEX in an exam, so this is stuff you would need to get used to doing. If you have OCD or something like that, then you are very cool, because all it means is you're going to write very neatly and you're not going to make mistakes. So that's like proper dope stuff. Like, I'm so jealous, like legit. But anyways, it's fine. We'll just stick to this handwriting. It is what it is. So y is equal to 2 to the power of x, right? Getting the inverse of this, we said y, you make it x, x, you make it y. And then all you want to do now is this. You see this here. This is x is equal to 2 to the power of y. Now what that means is you want to make y the subject of the formula. If you're going to make y the subject of the formula, you have to isolate y, which is fine. You isolate it, and then you put log with your base here, and then this value has to go there. You see, always, that's how logs work. You will have log here with a base somewhere there, with your value here. That will always be equal to your exponent. You see, if you want to isolate an exponent, you isolate it, you put log with that base of your exponent, and then the value here. Because remember, initially it was like this. You had a base, you had an exponent, and then you had a value. You see, so all you have to do is just shuffle. The exponent is what you want, so you put that on its own because that's what you want anyways. And then your log, whatever the base of your exponent was, becomes the base of the log. That's what we refer to this as. It's the base of the log. It is also the base of the exponent, and then the value just goes here. So this is actually done. The reason why this is done is because they said we should have our equation in the form y is equal to. So if you want, you could have y written first, but that's not going to lose you your marks. I mean, come on, you're done. But anyways, let's just put it like that. Y is equal to log 2 with x there. If they specifically wanted you to have it as, let's say, this, if they wanted you to put it in this format, then you do that. But they say just write it as y, so this is perfect. You know, it just means if you do this, you might lose a mark, which is just mean. But yeah, don't do stuff like that. Just do what they want, you know. When you write an exam, you want to strike a balance, you know. You just want to almost imagine this cruel person that is just so demanding. But if you do what they want, they'll just give you your marks, which is what you want, you see. So yeah, give them what they want for you to get what you want, you know. Then you're both going to be happy, you and the examiner. So it says here, sketch the graph of G now. Indicate on your graph the coordinates of 2 points on G. Wow. Okay. That's very nice. So 5.3, right? Let's put here 5.3. We have a Cartesian plane, and then we should sketch the graph of G. So the graph of G, firstly, because it's an inverse of f, try and have your inverse line there. Have it, label it. This is going to, you know, perform wonders for you because, I mean, yeah, that's a mark already. And we said the inverse of your exponential graph. This is one thing you will learn over time with like exponential graph questions and all that. If this is your original graph, right, the inverse will need to look like this. And the reason you know that is, firstly, let's just do this. If you don't want to maybe remember this sketch, or rather, let's just take things step by step. You know, we don't have to rush here. We said this is your original graph, and then this is what the inverse is going to look like. The reason we know this inverse looks like this is because, firstly, initially, can you see that your line is avoiding the x-axis? So the inverse will be avoiding the y-axis. But instead of thinking of it like that, this is one thing you'll always be able to, you know, generate. This will become second nature with more questions that you work on. So let's just draw that graph of G quickly. You're going to have a curve there, and then the other portion there. Now to cement this further, they said we need to put 2 points that G passes through. So what we know is, you see this point here is just 0. Oh, I had to put a 1 there. The x value is a 0. The y value is a 1. You see. So the reflection of this point is this point here, meaning x and 1 just swap around. So if x and 1 swap around, it means that this is 1, this is 0. That's what reflection is. Reflection is just a scenario where all your coordinates for your original graph, they legit just swap around. Oh yeah, they legit just swap around. So this coordinate here, if you reflect it, the coordinates swap around. This coordinate here, if you reflect it, it's going to be maybe like somewhere there. Well, this is not to scale, but you get the idea. Somewhere here, right, on your graph, you're going to have a coordinate that is 16 and 4, because the 16 and the 4 have to swap around, you see. Those are the two coordinates we can indicate on our picture. Somewhere there, you're going to have 16 and 4. And then somewhere here, you're going to have 1 and 0, you see. Because that's what they want. You give them what they want, you know. Just don't argue. Can't argue with the paper anyway, so might as well just do the things. So you see, they say here, sketch the graph of G, indicate your graph. Indicate on your graph the coordinates of 2 points on G. So yeah, 1 point, another point. So you are safe. That's literally all you need to do here, because I mean, it's 4 marks anyways. They just wanted you to sketch. You sketched. They wanted you to give 2 points. You gave them 2 points. I mean, what more do they want? And you even gave them an inverse line. Oh, wow. That's like proper 4 marks there. You get your 4 marks. You perform a victory dance if you want. You don't always have to. But yeah. Why did I even say that? What victory dance? You're not done. You should. Well, all I'm trying to say is, again, in an exam, yeah, just have something that's going to keep you motivated, because it's a whole long time. I mean, 3 whole hours just sitting there, like, wow. You need something to keep you going. So, yeah. 5.4, right, says use your graph to determine the values of x. Okay, use your graph. Which graph now? Well, maybe both. You see, I'm like, what graph? I mean, we have two graphs. Specify. If it's graphs, put an S there, please. Well, anyways, you can't be fighting with your paper, so. But if things are not clear, remember, well, I'm not saying nothing is clear. This is all clear. We haven't even finished reading, but all this is clear. But as a side note, in an exam, if something is a bit shady, I mean, do not keep quiet and hope someone is going to ask. That's the worst thing that could happen, you know. Ask. You know, it's also going to be a way for you to, you know, off ramp from your paper. You know, you at least can talk to someone now. Because remember, writing an exam means you are quiet for 3 hours. So, yeah, also have breath mints with you. Because if you're quiet for 3 hours, trust me, you need something to. Yeah, why am I off ramping like this? Goodness. Yeah, the moral of the story was, in an exam, because you're quiet for 3 hours, make sure you take some breath mints. Okay, I'm done now. It says use your graph to determine the values of x for which this times that is bigger than 0. So you see how I worded that out. This is saying use your graphs, both of them. Let me add that S here. Well, I can't add it. It's going to look a bit messy, but I can do it here. Graphs. It's graphs. We need to use both of them. You see, like this question. So it's just saying use your graphs to determine the values of x for which this expression holds and this expression holds. So you see how this is a 2-mark question and a 2-mark question. It just means questions like this, don't overthink anything. There is, yeah, and then this here does not mean end. I mean, it's times. And this here does not mean work this out algebraically. No, you're going to blow your brains out. You're going to go kaboom. So don't do that. These kinds of questions, all they're saying is, you see f of x. F of x represents y values of f. G of x also represents y values, but g of x obviously represents y values of g. So all this is saying is, where will the y values of f multiplied by the y values of g give you a number that is bigger than 0? You see how simple that question is? It's a 2-mark question. That's why they're only giving it 2 marks, because that's all they're asking. They're asking you, where are the y values of f times the y values of g, giving you an expression that is bigger than 0. So all that means is, you need to look at your pictures. You need to look at your graphs. Luckily, they are both on the same Cartesian plane, so you're safe. So you need to ask yourself, where will this expression be bigger than 0? So to answer that kind of a question, what you do for yourself is, firstly, let's put here 5.4. Let me put here 5.4. They are saying, where will f of x times g of x be bigger than 0? This is essentially asking, where are the y values of f times the y values of g? Let's put here y1 and y2. Where are the y values of f times the y values of g bigger than 0? So technically, we know that this expression will be bigger than 0 if you are multiplying a positive number and a positive number. You see, this expression will hold. Or if you're multiplying a negative number with a negative number as well, you see, this expression will hold. So that's what this question wants you to do for 2 marks only. That's why you'll see they'll never offer too many marks for this, because that's it. Don't work this out algebraically. That's not necessary. Would not recommend. So here we need to work out where will f and g both have positive y values, and where will f and g both have negative y values. So let's look at our sketches. So we need to work out where they are both having positive y values. Let me actually bring this closer to our statement there. You see, there we go. We need to work out where both of them have positive y values. So let's check that out. Can you see that this graph of f has positive y values everywhere? You see, it has positive y values from negative infinity all the way to positive infinity. So the graph of f has positive y values everywhere. The graph of g, though, only has positive y values here. You see, your graph of g has positive y values here only, but then f has it everywhere. So you want to check where they will both have positive y values at the same time. And you can clearly see that they will both only have positive y values from here going up. You see, this has positive y values, and this also has positive y values, you see. So that's the point where these are the points where they both have positive y values. So, and you can see that's starting off where x is a 1 going all the way to positive infinity. You see, that's one of the portions where the graph of f has positive y values and the graph of g has positive y values. So we are going to give our answer like this. The first answer has to be x needs to be bigger than 1. X needs to be bigger than 1. You see, because if you're considering x values that are bigger than 1, then you are talking about portions where your y values are positive times positive y values as well, you see. So this expression will be satisfied, you see, because this is basically asking where will f have positive y values and where will g also have positive y values, because when you multiply them together they will give you a positive number. So this is our first set of answers, you see, all the x values that are bigger than 1. The next portion here, we said we have to look at where both of them have negative y values. So for this case, we know that if they both had negative y values at some point, it means that you would have had like a negative value times a negative value, which is a positive number, because you see this here would be a value that is bigger than 0. So the expression would hold. However, can you see in our picture, there's no portion where the graph of f will have negative y values. You see, the graph of f only has positive y values. You see, it's only above the x-axis, so it has no negative y values at all. So in our case, there is no scenario where this is playing out, you see. So we would have to disregard that option. If you would need to not worry about working that out, because I mean that does not exist anyways. So for this kind of equation, 5.4.1 actually. Yeah, why did I put 5.1? 5.4? No, man, it's 5.4.1. 5.4.1, this is your final answer. That's it. X needs to be bigger than 1. That's why that's just a 2-mark question. So yeah, if these kinds of questions were stuff that you used to struggle with, I'm sorry, but you are okay now. You know, the more practice, these are going to get much, much easier as well. And yeah, you were probably wondering, why are there always 2 marks when you have to do so much? Nope, you don't have to do anything at all. Just use your pictures and answer these kinds of questions that you would need to answer. So here now it says, for which values of g determine for your value for your graph or graphs or graph or whichever. Oh, what was I doing here? Wow, the graphs were supposed to go here. Y'all probably noticed, but I didn't. Nope. Scratch that out. Yeah, excuse me for all this mess. If you're not a fan of, you know, all this kinds of stuff, I'm sorry, my bad, I'm sorry. Just try and imagine it's not there. So here it says, use your graph to determine the values of x for which g of x will be smaller or equal to 1. You see, that's a 3-mark question. They are saying where, let's put here 5. Well, why are you so blurry, man? Be clear. 5.4.2. They are saying where is g of x going to have y values that are smaller or equal to 1. Remember, this represents y values. You see, that's what g of x is, and f of x and all that. They're asking us, where is our graph of g? This is our graph of g. Oh yeah, and when we sketched our graph, the last thing you can always do for yourself is label it, let's just label it here. So this graph of g, you can label it g of x. Yeah, this is where your fourth mark is actually going to come from. So that's why this is a good channel, because we go through what you need to look out for in question papers and all that to get all your marks. So if you did not have your reflection line there, just have it there as a habit. If someone feels sorry for you, they'll probably give you your fourth one there for having that there and not G, because that will be indicating that it is G, because G is the reflection and G is this graph that you drew. But let's move on with our question. G of x, they're asking, where does G of x have y values that are smaller or equal to 1? Y values that are smaller, oh no, it's a negative 1. And again, y'all watching noticed, and I didn't, because I only noticed now. And again, all these bloopers, they're technically just stuck there. Unlike when I have the tutorials on my other math channel, because there, things are, I can edit out. It's a different format anyways, because I'm technically writing on the screen, your screen and stuff like that. And obviously, again, shameless plug, if you're not familiar with that channel, my other math channel, where I go through full tutorials on these topics individually and stuff like that, the format there is much nicer, much better. It's called Bright Young Brains. So if you're already following Bright Young Brains, high five to you, big up. Let me know in the comments so that I can say thanks. So yeah, the other channel is called Bright Young Brains. You can just search for Bright Young Brains, it'll pop up. I have a ton of tutorials. They're way more than this channel. I think at the making of this video, I have 87 there. But the time you will be watching this, I probably have over 100 there. No doubt. So we need to work out where this graph has y values that are smaller or equal to -1. Okay, so for you to answer a question like this one, you see this one here, we can easily work this one out algebraically, because it's not difficult at all. However, we need to take into consideration how our graph of g, remember our graph of g is this equation here. It is log with a 2 here with x there. So for you to answer this question, you need to remember that this you can answer algebraically, in the sense that you can have the equation of g of x, which is log 2 with x here. Where is that smaller or equal to -1? So in terms of you answering this question, right, the first thing you want to do is, can you see how this is worded out? Remember, you now have here a log with a base, with a value, and an exponent. You see, that's what we are having here. Let me make sure this is not blurry. You have a base, you have a value, you have an exponent on the other side. You see, base, value, exponent. That's what you have here. So for you to solve for x, you need to reverse that process, meaning this is representing an exponent. So you're going to have an exponent with a base. So it's technically 2 to the power of -1, because this is your base, this is your exponent, and then this is just your value. You see, this is clearly showing you that your x values need to be smaller or equal to this. In your calculator, this is just a half. So this is telling you that your graph has y values that are smaller or equal to -1, where x is smaller or equal to a half. However, this is not full, this is not complete. The reason is, this is saying that our graph will be smaller or equal to -1, where, let's pretend this is where x is a -1/2. Let's just pretend. You see, if x is a -1/2 here, right, it just means that going to the left, those are, if you're considering x values going to the left, those are y values of g, where your graph is smaller or equal to -1, which is fine. So all it means is somewhere here, right, the y value there is a -1, you see. So your graph will be smaller or equal to -1 from this x value going all the way down, or rather, sorry, from this x value going all the way to all the x values on the left. However, can you see that our graph will never touch our y-axis? So we need to indicate that our x values do need to be smaller or equal to a half, yes. However, these same x values need to, wow, oh my goodness. I was about to say 2b. Let's put a 2 here, tiny one. Need to be bigger than 0. You see, your x values need to be bigger than 0. You see, because they can never touch this line there. So here you need to say that x needs to be bigger than 0. So your final answer for you to have these two, you can have the x needs to be smaller or equal to a half, and then those same x values need to be bigger than 0, you see, because that's what this statement is saying. X needs to be bigger than 0. This is saying x needs to be smaller than or equal to a half. You see, x needs to be smaller than or equal to a half, but then those same x values need to be bigger or equal to, no, just bigger than 0, you see, because it cannot equal a 0 there. So don't be blurry. That's what you'd need to do for 5.4.2, and my suspicion is that this is technically where you probably started off with this paper, or even the previous functions question as well, which is totally fine, because remember in the description you have all the you have timestamps of where I started working on like specific questions in this past paper, in this grade 12 maths past paper 2019 November, or November 2019 grade 12 maths past paper memo. That's what you probably, well, all I'm trying to say is, yeah, let's just move on, because yeah, I'm about to speak here and run out of words. You see, that's the thing with the other channel that I mentioned. Whenever I feel like I'm about to off ramp, I literally just stop and then I edit it out. I cut those stuff out. You never see them, obviously, because those tutorials are short, they're quick, straight to the point. They are, the longest one there is I think 20 minutes or something. The shortest one is like 3 minutes. So they literally range between, most of them are just under 10 minutes, because yeah, these kinds of tutorials, these ones, you can literally look through them or go through them over like a whole week, maybe like one day in the week you watch like 10 minutes and then 20 minutes and then maybe another 20 minutes, and then before you know it, you've watched the whole thing. And I think that's going to be very helpful. Like your brain is going to feel like, you know what, I've gone through a whole paper. Or you could literally go through a whole paper yourself, and then you can use this to mark, because this is like a a virtual memo. Well, it's not a virtual memo because I'm not like AI or anything, or am I? But all I'm trying to say is here you at least get an explanation of what the memo means and stuff like that. And then the lucky thing is, or the good news is, with most of these questions I'm literally just doing them as I go, because why not? So 5.4 though, 5.5 rather, 5.5. Why is this question so far from the rest? Well, let's just try and keep these together, because I mean, this here is talking about H and then F, and then it's just like manje, why? So for this 4-mark question, right, it says here that if h of x is equal to the equation of f with negative x, where x is, calculate the value of x for which this here is equal to 15/4. So you see, that's the funny thing with maths. It's not like haha funny, it's just like weird. It's like, why can you not just ask this normally like English? Well, that's the thing, you see, maths is not English. So your questions, they're not going to be they're just not going to feel as though they are making sense, but they actually are. So this is what I mean. This is just saying you have an equation of h, right? Now for you to get that equation of h, you need to throw in a negative x in the equation of f where x will be. So what that means is, before we look at the question, all this is saying is, in your equation of f, what's our equation of f? If you remember our equation of f, it is just f of x is equal to 2 to the power of x. This is what f is. They said h of x is equal to f with negative x there. You see? That's what they said h of x is. So all this means is, your equation of h of x, it is literally just you taking the equation of f, and then where x is, throw in a negative x. You see, we technically have 2, and then where x is, you want to throw there a negative x. You see, that slot, you just throw in a negative x there. That's what this equation is. You see, h of x is equal to f of x with a negative x, where x would be. You see, because this is 2 to the power of negative x. You see, that's what h of x is. They're just giving it another name because it's now not f of x exactly. It's f of x with negative x where x is. So with that being said, right, for 4 marks, 4 marks. Well, we just came from getting 4 marks as well. You know, we just got 2 marks here, 2 marks there. So 4 marks, we're used to getting 4 marks. Might as well just get these 4 marks as well. So let's get it. So they said here, for which they said g of x is equal to f of x minus x. Calculate the value of x for which f of x minus h of x is equal to 15 over 4. And that's a 4-mark question. Okay, that's very interesting. So big issue again. Remember, if this is amongst those questions that you look at and they just make you go, oh no, what is going on, then all you want to do is just move on. You know, move on to other questions, move on to stuff that you will be happy with. Don't force yourself to strain your brain into what is this, into solving something that's going to make it overheat and depress it and make it not function at its optimum. Because remember, in an exam you need to make sure that you are, well, I'm not going to say happy the whole time, I just mean make sure you don't have things that bring your mood down. So if you look at this question and you're like, oh, what's going on, I don't know where to start or whatever, then again, move on. You can highlight it on your question paper and then move on and then come back to it later. So let me just let's dive into this question now. Kind of ran out of battery, but I'm back now. So it says here, let's just carry on. We need to lay out this expression, right? And then work out where f of x minus h of x is equal to 15 over 4. So let's just look at that. So they're asking us to work out where is f of x minus h of x equal to 15 over 4. So we already worked out what h of x is, right? They said h of x is this expression here, and we said now all we need to do is, we already know that the equation of f of x is just 2 to the power of x. The equation of h of x, we said it is just x to the power 2 to the power of negative x, and then we need to work out where is this equal to 15 over 5. And technically this is a question that's asking us to solve for x. Now the good news is, can you see that here we have 2 to the power of x, and then there's another 2 to the power of x here. Now this 2 to the power of x looks a bit funky because it's a negative 2. It's 2 to the power of negative x. You see, what you want to take away from this question is this here. You could look at it as, here we have 2 to the power of x minus 2 to the power of x, and then the whole thing here is to the power of negative 1. You see, reason is, remember here you have negative 1 times x. Remember, x times negative 1 is the same as negative x. You see, this is just an exponential law because you have a tiny negative 1 there. So if you take the tiny negative 1 away and you put this in brackets, it's still okay. So the reason I've done this is, when you are looking at it like this and you need to solve for x, this is clearly what's stopping us from solving for x. It's just too chunky. You see, x is on the exponent position. So this is clearly one of those questions where you can use the k method, right? Let k be equal to 2 to the power of x. What that means is where we see 2 to the power of x, we're going to throw a k there because that will make the question look a bit lookable, if I can put it that way. And then once we have done that, we are going to firstly solve for k, and then after solving for k, we will then just use this expression here to get our value for x. So yeah, I mean, so far so good, I guess. So working out a value for k here, what you want to take note of is anytime you see an expression to the power of a negative value, all you do is, firstly, this here, if you want to write it as a positive exponent, you want to take the k under its coefficient. So the coefficient of k there is just a 1. So you put a 1 there, and then the k goes under it, and then its exponent becomes a positive. So if there's a 2 here, you'd have a 2 up there with k and a positive 1 down there. So here this is equal to 15 over 4. And at this point in time, you can see we can work with this fraction first. We can get an LCD. Now, the good news is you don't have to get an LCD for everything. That's not necessary. You literally just need to get an LCD for the portion that's relevant to you here, because we just want to make this a fraction, because you see there's a fraction there as well. Now, if we make this here, if we get an LCD here, we just need to multiply by k at the top, k at the bottom. This is technically multiplying by 1. You see, so you're not changing your expression. So you don't have to do this on the right hand side as well, because you see multiplying by 1 is not changing anything. Because that's a question I always get all the time. Like, why do we not have to multiply or get the LCD for both sides? You don't have to, because you're just multiplying by 1 here. Meaning you'll have k squared here minus 1, the whole thing over k, equal to 15 over 4. You see, you now have a fraction and a fraction. Now this is good news, because anytime you have a fraction multiplied, or a fraction equal to another fraction, if you don't want to have fractions there, you can just cross multiply. You see, it's always the bottom times this top, the bottom times that top. So it's going to be the bottom times this top, which is just 15k. The bottom times this top, which is just 4 with k squared minus 1. And I prefer using k's because it helps you remember that your question is actually not bad at all, because you see, working with exponents and stuff like that, and this may not be very nice, so you can just do this. So here you'll have 4k squared minus 4 equal to 15k, and then here you have 4k squared minus 15k plus 4 equal to 0. You see, now this is clearly a quadratic equation, and yeah, by now you know quadratic equations definitely make the world go round. If you don't agree, then I'm sorry, but yeah, if you think quadratic equations make the world go round, just let me know in the comments. Just put there, quadratic equations do make the world go round. So if you use your quadratic equation here, which I am going to use right now, you basically need to say k is equal to negative b plus minus b squared minus 4ac over 2a, you see. And then k here is minus b plus minus b squared minus 4a. And then our value for c is also a 4. Yo, so many 4s here. Yay. The whole thing over 2a. Our a value is just a 4. Now, the thing with the quadratic formula is, you see, you have to also just concentrate, which is the blunt thing to keep note of or take note of in an exam. Just concentrate. Don't lose marks because of a lack of concentration. So you want to put all this nicely into your calculator, and then your two answers there, you'll see that, let's see here, we're getting negative a quarter, or k is equal to positive 4. You see, so we now have a value for k here, which we can use to get an x value for our question, you see, because our main question is to just get an x value here. Now we can do that by throwing in a value for k here and then get an x value. So let's start off with this one. If you were to start off with this one, you'd have negative a quarter is equal to x squared. Now the problem is here, if you wanted to solve for x, you would have said log the base with the value here equal to x. And then in your calculator, this will give you an error, you see. And this is not applicable. I don't even know what I'm doing here. X is equal to not applicable. Wow, X is not equal to not applicable. Let's just remove that. At this point here, you can just put there not applicable, you see. Because this will give you an error in your calculator because you cannot have a value to the power of an exponent that gives you a negative number. Yeah, it just doesn't work like that, you know. Yeah, it just doesn't work like that. Yeah. So if this base is a positive, obviously. So here, let's test our other portion of answers. You see where k, we know that it is equal to 4. So it just means up here, you see where k is, we're just going to drop a 4 there. So that's going to give us 4 is equal to 2 to the power of x. And then this is giving us 2 to the power of 2, which is 2 to the power of x, which is giving us x as 2, you see. Because, yeah, that's it. 2 marks. No, 4 marks. X is equal to 2, but we are going to get 4 marks because that's what they wanted us to do. Calculate the value of x for which this whole thing here is equal to 15 over 4. So x needs to be a 2. So you get your marks, you move on, yeah, and you stay happy because in an exam, that's the one thing that's going to keep you going. Don't be sad, don't be depressed, don't be angry at anybody, don't be angry at your paper because that's definitely not going to help you with anything. The least you can do for yourself is make sure you finish your paper. Make sure you see all the questions because there'll be stuff there that you will like. So yeah, the next question is financial math. So if you jumped to this timestamp, welcome. If not, if you have been literally watching the whole thing bit by bit, maybe throughout the week or something, and this is where you are now, big up, y'all, big up. Like, yo, that's super dope. So I think at some point I'm going to have like a poll on my stories or something on IG or something at some point in time. I'm just gonna try and find out if there's anyone that has like watched any of this from like start to finish in one go, which is gonna be quite rare, but whoever does that, I mean, just if you do that once, then let me know. I wanna say thanks. So anyways, no, thanks for studying and thanks for watching because yeah, you know, this is yeah, it's a lot. But anyway, so it says 2 friends, Kuda and Tabo, each want to invest 5,000 for 4 years. And yeah, by the way, there's just load shedding right now. It literally just went dark. Crap. So it says 2 friends, Kuda and Tabo, each want to invest 5,000 for 4 years. Kuda invests his money in an account that pays simple interest at 8.3% per annum at the end of 4 years. He will receive a bonus of exactly 4% of the accumulated amount. Tabo invests his money in an account that pays interest at 8.1% per annum compounded monthly. Whose investment will yield a better return at the end of 4 years? Justify your answer with appropriate calculations. Yeah, so you see, there's a lot of stuff that they said here. Way too many things have been said here. And reading it was literally just reading it, which is fine, but you read it and then you need to read it to understand. And just a side note, if my screen just goes black and then I come back, it's obviously because of the load shedding and because this battery would have died and all that. But, you know, it is what it is. So let's just carry on. 2 friends, Kuda and Tabo, each want to invest 5,000 for 4 years. So we have 2 people here, right? 2 people. We have Kuda that has 5,000 and he wants to invest for 4 years. And then we also have Tabo. You see, Tabo. If your name is Tabo or Kuda, let me know in the comments. So Tabo, oh, I should have put a capital letter. My bad. I'm so sorry. My bad. Sorry. And then this is 4 years also. So they each want to invest 5,000 for 4 years. However, they said Kuda invests his money in an account that pays him simple interest. Why would he do that? Simple interest at 8.3% per annum. So Kuda invests, his interest rate is 8.3%. And then this is simple interest, which is very weird, but okay, let's not judge. And then Tabo says he wants to invest at the end of 4 years, right? And it says Kuda invests his money in an account that pays him 8.3% per annum. At the end of 4 years, he will receive a bonus of exactly 4% of the accumulated amount. So when all this is done, when he has invested for 4 years at this interest rate, whatever he would have accumulated to, they are going to add 4% of that and then give that to him as a lump sum. Okay, that's nice. And then for Tabo though, he says Tabo invests his money in an account that pays interest at 8.1% per annum, compounded monthly. So Tabo invested for 5 years, invests 5,000 as well for 4 years though, and then his interest rate is 8.1%. 8.1%. You see, that's his interest rate, and then here it is compounded monthly. That sounds better. I'm betting that Tabo is in a better space here. So this is compounded. Ooh, pow with a U. Compounded monthly. Okay, so these two scenarios, they're asking whose investment will yield a better return at the end of 4 years. Justify your answer with appropriate calculations. So this question, you see, it's out of 5 marks. This is 5 marks given away here. So all you want to do is you want to stay calm and make sure that you get every single mark because you deserve it, you know. So here, this is for Kuda, his simple interest scenario, right? We know that A is what we're looking for. However, he invests 5,000. That's our P value. So A is equal to 5,000. And then our interest, we know it is 8.3%. So if you want, in your calculator, obviously this is going to give you 0.083. And then this is multiplied by the years, which is 4. Wow, I kind of swapped these two. No, I didn't. It's perfect. So in your calculator, right, let's put all this in the calculator and see what we end up with. So in your calculator, we can clearly see that, let's see here quickly. Just take this calculator. Casio calculator. If you don't use the Casio calculator, then I'm so sorry because you are missing out. This calculator is just so easy to use. It is going to save your life. So let's see here, times 4, and then let's put this there, equal to 6660. Ooh, that number. But anyways, this is not all Kuda is going to get, you see, because with Kuda, he's going to get 4% more. So we need to work out 4% of this number. Highball, what's going on now? 4% of this number, right? And then add it onto the 6,000. So we need to say 6,660. We need to add 4% of that money to see how much he's getting at the end of this 4-year period. So let's work out what is 4% of this number. So this number here times 4%, shift percent. This is giving us 2664. Okay. 26, whoa. This is 2664. You see, it's about to make a very silly mistake, which is like super weird. So this number plus the 2664 plus, let's see here, this is giving us, okay, that actually works out. This is 6926.4. You see, 6,926.4, which is not so bad. I mean, that's what he's getting, but let's find out how much Tabo is getting. Remember, I said I'm banking on Tabo getting more. So let's see how much Tabo is going to get here. Tabo used compound interest. So it's P1 plus I to the power of n. And always try and write your formulas because, I mean, you know, why not? Why not? You have literally nothing to lose. Whoa. You couldn't see that. Wow. Wrote out the formula, wrote out everything. P is 5,000. And then our interest, remember, it is 8.1%. 8.1% over 12 because it's being compounded monthly. And it's for 4 years. compounded monthly. So that has to be 4 times 12 there. Now, if you put all this in your calculator, let's see what this is going to give us. So if you put all these values into your calculator, this is giving you, let's see here, 5,000 Rand, calculator, 5,000 Rand, 1 plus, let's see here, 8.1 shift percent over 12, the whole thing to the power of 48. This is giving you, oh no, Tabo, why? Why, Tabo, why? Tabo didn't get more money. But anyways, this is this is to 2 decimal places, so that will be 0.71. So, oof, big oof. Snap, man, Tabo didn't get more money. I can't believe it. Well, okay, that's okay. So because Kuda got 4% more at the end of everything, Kuda definitely gets more money, you see, because yeah, so here you need to state that. Therefore, Kuda, so they had asked whose investment will yield a better return. Kuda's investment. You see, we're not gonna say Kuda's investment gets the what. No. This is good enough. Kuda's investment. You see, they ask whose investment will get a better return. Kuda's investment. That's it. These calculations are where your other 5 marks are going to come from. So, well, justify your answer. You see, you should justify it with appropriate calculations, not justify it with more words. No, you say those words, you save your ink, you move on. So 6.2 says here we have 9 years ago, a bank granted Mandy a home loan of 525,000. Okay, that's nice. This loan was to be repaid over 20 years at an interest rate of 10% per annum, compounded monthly. And then it says Mandy's monthly repayments commenced exactly 1 year after the loan was granted. Yeah, you see there, I literally could feel myself just reading that. But yeah, someone got a loan. This is the interest rate. It's compounded monthly, and they have to pay it off for 20 years. However, here it says Mandy's monthly repayments commenced exactly 1 month after the loan was granted. So she didn't skip any payments. Well done, Mandy. Mandy decided to make monthly payments of 6,000 Rand instead of 5,066.36. How many payments will she make to settle the loan? So it's a loans question. I mean, you really don't need any more words than that to know that you're going to use the P formula. So with this question, because it's a loan question, we need to use our present value annuities formula in this financial maths grade 12 question. So let's use our financial maths formula, the P formula. So the P formula, which is our present value annuities formula, it says here X with 1 minus 1 plus I, the whole thing to the power of negative n, closed bracket, and then this whole thing over I. And then remember we said you don't have to cram any formulas. You know, your formula sheet will have all your formulas, so you just use them, you know. So the only thing that we know about this question is we already know that the loan that she has to pay off is 525,000. That's for P. Whoa. Her monthly installments, see, I'm finessing this because in an exam you don't have TPEX. So X is going to be 6,000. They said 6,000 for X. And then interest is going to be, how much interest did they say? 10% per annum. Compounded monthly. Whoa. Yeah, 10% per annum, compounded monthly. And then our value for N, that's what we're looking for. So this seems like a fair question for how many marks? 5. Woo, wow. Wow. I'm not a big fan of financial maths, but this is where your marks really come in, you know, because I mean, this is not going to be a lot. It's just like 5 marks, 5 marks, 4 marks. That's like 14 marks. This is close to 10% of the whole paper. You see the difference between 69 and 79. But why would you want 79? No, the difference between 70 and 80. this is what this question paper is literally, yeah, giving us. It's giving us 10% of the paper. So yeah, P is 525,000. Our value for X is 6,000. And then our value for I, it is 10% over 12, the whole thing to the power of negative n. Oh, okay. I see where our 5 marks is coming from now, because you see here where n is an exponent, and you know, if we're going to isolate this exponent, they have to give us marks for that, because that's a lot of work, you know. You don't do stuff and not get marks in maths. That's not how it works. So I was just looking at like a post that Metric Memes 2020. No, yeah, is it Metric Memes 2020? Yeah, Metric Memes. No, memes. Huh? What's that meme page called, man? Yeah, Metric Memes 2020. So one of the guys in the comments said that in Maths Lit, they said Maths pure guys will never know the beauty or will never experience getting marks for writing your name. I actually don't know how far true that is, but if people do sometimes get marks for just writing their name, wow. You're another off-ramp. Shucks, man. Get in the zone. So in an exam, if you're like off-ramp and you're thinking of other things, just stop. So here, we need to isolate n. But the easiest way to isolate n is to not do it like this. You see, this is not fun to do. What you want to do is, well, forget the word fun. All I'm trying to say is, if you're going to isolate n, right, try to do that before throwing in numbers, you see. Meaning your expression here, right, for p. Isolate n first. And you see here, for you to isolate n, you're going to firstly multiply by I on both sides, you see. So this I is going to cancel that I. And then you technically have pi is equal to x with 1 minus 1 plus I to the power of negative n, the whole thing like that. And then here you're going to divide by x on both sides. So you're just going to have here pi over x is equal to 1 minus 1 plus I to the power of negative n. And then this is what you want to do. You see here, this is a positive number. So you want to take it to the right. And you see this is a negative number. It's best if you take it to the left, because you see, n here is what we're focusing on. So it's better if its base is a positive number. So when you take the pi over x to the other side, it's going to be 1 minus pi over x. And then you're just going to use logs here, because technically you want your base to be alone. So you put it on its own, and then you have log here. Your base is just 1 plus I, and then your value here is just 1 minus pi, the whole thing to the power, no, the whole thing over x, like that, you see. And then obviously when you will want to isolate n, I'm just going to finesse this question. Technically you're going to divide by negative a 1 on both sides. So this will become a positive, and then this will become a negative. So in an exam, feel free to do that as well, because you see, oh yeah, load shedding, wow, just as I'm fuming. Well, give me a second. Okay, and we're back. So let me know in the comments of like a time when, yeah, load shedding hit at the worst time. But it's not so bad, because I mean, you know, yeah, we're back now. Well, the labs are not back, but I'm saying we're back to recording and stuff. So let's just carry on and not waste anybody's time. So we said here, we just had to use logs to isolate n, and then the only issue is our n was a negative, and then this was obviously just a positive. The only issue is we know that to have n alone would have needed to divide by negative on both sides, and then dividing by negative on both sides, this is going to leave us with a positive n, and then this here obviously a negative value for all that. So this is going to give us a value for n now by just throwing in all our values. So here we know that this is going to be negative log, and then we have 1 plus our interest, which is 10%. Compounded monthly, we have to divide by 12. And then the whole thing here, we have 1 minus 525,000. The whole thing over, hey, what am I doing here? Yeah, 525,000, right? But then this is being multiplied by the interest, which is over 12. And then that whole thing is over 6,000. So it looks like a lot, but all this comfortably fits into your calculator. And this is what I mean, you see. So in your calculator, if you put the, technically you need log. Where's the log button? Oh, log. And then you need to put the negative. And then obviously here we said you need to put in the, let's put it like that so that you can see both. So you need to put your what you call your log button, and then here we have 1 plus 10%, the whole thing over 12, and then we go in there, you see, and then it's just 1 minus a fraction, and then it's like 525,000, and then this whole thing is over, whoa, you see I did it again. You have to times by our interest, which is 10% over 12. Where's the 45 coming from? Over 12. And then the whole thing here over 6,000. You see? Put all that in your calculator and you're getting here your value for n is 157.4. So this will be perfect. You see, you have gotten your value for n there. So technically you cannot make 157.4 payments. So we know that this would need to be considered as therefore n is equal to, or rather therefore monthly, let's put here monthly payments equal to 158. You see, because you cannot make 440, you cannot make 157.4 payments. You would have to make a full payment to accommodate this 0.4. But then this 0.4 tells you that you're not going to make a full payment of 6,000 as your final payment. You see, that's like another tutorial for another day. Not exactly. You can actually just go to the other math page where you have like bite-sized tutorials there. There's a tutorial on getting the final payment on a loan. So you can look at that if you want. But yeah, for this question, they just wanted us to get the number of payments that she would need to make if she was making payments of 6,000. You see here, Mandy decided to make monthly payments of 6,000 instead of the required 5,066.36. How many payments will she make to settle the loan? She will make 158 payments. Ooh, yeah, net buying houses, guys. Yeah. After making monthly repayments of 6,000 for 9 years straight, Mandy required money to fund her daughter's university fees. So she made these payments, right, for 9 months only, for 9 years only. And then he says Mandy required money to fund her daughter's university fees. She approached the bank for another loan instead. No, she approached the bank for another loan. And then he says instead the bank advised Mandy that the extra amount repaid every month could be regarded as an investment, and that she could withdraw this full amount to fund her daughter's studies. Calculate the maximum amount that Mandy may withdraw from the loan account for 4 marks. Okay. Chill, paper, chill. I mean, like, relax. Like, hold on. Well, so this question actually it's actually not that bad if you think of it for like a second longer. Because all they are saying here is, you see, this 5,066.36, this is an amount to say that if she makes use of the whole 20 years, wait, it says this loan was repaid over 20 years at an interest rate of 10% per annum compounded monthly. Mandy's monthly repayments commenced exactly 1 month after the loan was granted. Mandy decided to make monthly repayments of 6,000 instead of the required 5,066. So what this is trying to tell us is that if she was to make use of all these 20 years to pay off her loan, then she would only need to have been making 5,066 rands in terms of her monthly payments. However, because she was making monthly payments of like 6,000 instead, it means that she was going to pay off her loan much quicker. So just to show you an example of that, if she was to make these 5,066 rand payments, right? If this was, let's say, the monthly payments that she was making, let's put here our P formula, then this would be like 1 minus 1 and then plus I, which is 10% per annum compounded monthly, the whole thing to the power of 20 years times 12 because it's compounded monthly. This year 10%. Let's see if this was her monthly installments. Let's see if she was going to pay off the loan in 20 years. Whoa, what's going on here? Oh, haha, you see, I forgot to put a negative there. That's why I'm getting this negative number, you see. I'm using the P formula, but I did not put in my exponent as a negative value. So that's not a big deal. You just go back here and you fix it, you see. You can put this in brackets if you want. You don't have to, but you can, because brackets are good. So this is clearly showing us that she will, if she was to make use of the whole 20 years to pay off her loan, then this is the month. Whoa. If she was going to pay off her loan in 20 years, right, this is the monthly installment that she would have needed to be paying. But then she chose to make monthly payments of 6,000 Rand instead, meaning that technically, let's write here 6.2.2. What it means is for in her case, she was technically making, let's see here, 5,066.36. Let's see what's the difference between these two numbers. 6,000 minus 5,066.36. This is giving us 933.64. So technically, she was paying 933.64 extra, you see, so that she can pay off her loan quicker. But then, technically, this is saying that 9 years while doing this, she just needed some extra money. So the bank was like, okay, fine, don't worry about getting another loan. What we are going to do is the 933.65 rands extra that you were paying, we are going to take those as you making investments of 933.64 rands every single month for these 9 years. So this bank is really nice. This bank is very fictional because banks are not this nice. Yeah, let me just put that out there. But hey, I don't work at a bank, so I'm not trying to gun at anybody. I'm sorry, but yeah, this is just such a nice scenario. You know, it's very nice. Earth should become more like this. So all these extra amounts, they're like, you know what? We are going to take those as you having to have been making investments of this much into a savings account. And then these investments, technically they're going to still give her interest of like 10%, because you see there's nothing extra here, so you still use that 10%. So let's see here, 10% here, compounded monthly, and then N, we know that's for 9 years, but then because it's compounded monthly, N has to be 9 times 12 there. And then our value for F, that's what we're working out. We need to work out how much will technically be available for her after these 9 years of making these payments, because you see here they're saying calculate the maximum amount that Mandy may withdraw from the loan account. So let's see here, our F formula, again, your future values annuities formula, that's on your formula sheet, so just use it. Let's see here, 1 plus I to the power of, this is actually kind of funny because I'm just using my head on this, but obviously every time I write something from my head, I always double check. And yeah, it looks fine. So let's see there. If we're going to work at F, luckily this is already, nicely packed. We don't have to do anything. We just need to throw in our numbers into our formula. And then after throwing in all these numbers, let's see. 9 times 12. What is 9 times 12? I'll just leave it as 9 times 12 here because I'll just put that in the calculator. And then the whole thing, we have another bracket there. Don't mind my handwriting. It's a special case. And then 10% here over 12. And then here our value for F. Let's put all this in the calculator. Let's see what it's going to give us. So we have a fraction button. And then we need the 933.64. And then we have, let's put another set of brackets. 1 plus 10%. And if you'll note, I like using the percentage button because, it's just nice to use instead of decimals and all that. But, each to their own. and then minus 1 here, and then the whole thing over 10%, and then this is 12 there. Yeah. There we go. So this is telling us that she will be able to take out 162,503 point what 0.5083. However, because your papers will always tell you to round off to 2 decimal places, you just round off to 2 decimal places. You don't fight with them, just give them what they want. Sorry, this was supposed to be a 1, and oh boy, you remember, in an exam you don't have TPEC, so you have to finesse your answers. This should be fine. If you want to scratch it out, maybe you do this and then you rewrite it. Your choice. I hope me doing this is not irritating anybody. Like, no, you're making it look dirty. I'm sorry. My bad. So that's what we needed to do for this question here. It gave us 4 marks, and let's take note of those marks. We got this 5, we got those 4. So yeah, I mean, it's popping. It's like proper popping, because it's been marks on marks on marks on marks. Well, still need to get more marks, because yeah. Just when you think you're almost done. Yeah. This is why you never want to go in an exam hungry. I would not advise anybody to do that. Please make sure that you have slept enough, because it's a lot. It's so much. I mean, wow. So question 7, right? Well, I think this is where things start to get a bit okay, because this is just differentiation, and differentiation is okay. Differentiation is your friend. Don't hate differentiation. Differentiation does not hate you. So let's see here. Question 7.1. So by the time you get to question 7, things will definitely, start to get, well, this is literally just like the closing stages, right, of your paper, one way or the other. So we need to work out here. It says here, determine f prime from first principles if it is given that f of x is equal to 4 minus 7x. Okay. So, excuse me. Whoa. This is clearly a common question in all exams. I mean, you always get a question like this one. And if you literally just got here by using the timestamp, just let me know. Because, that's the idea with these memos, right? The idea is to, have as much information in the description so that you could literally just go to like a specific time where a specific topic was being covered, you see. So here it says determine f prime. So we are given here that f of x is just, let's see here, f of x is equal to 4 minus 7x. And this is a 4-mark question, you see. They want us to determine f prime using first principles. Now the big idea is, if you don't use first principles, you should just expect to get nothing or a single mark if you're lucky. So using first principles, we already have our first principles formula, which is on your formula sheet, right? It says here lim. You see, this is what happens when you don't look at the formula sheet before you write your formulas. You almost end up making, useless mistakes like what I was about to do there. I was about to put f of x first, or f with x plus h, excuse me. Anyways, so this whole thing here is over h, and then we know that firstly, what I would say is this expression, all it means is in your equation of f, just throw in x plus h where x is, you see. So you're going to have here lim, and then as long as you still have your h somewhere in your expression, just have lim with h tends to 0 there all the way until you're done, you see. So h here goes to 0, and then we know that here all we said was you need to put the x minus x, you need to put the x plus h where x is, and then minus f of x, meaning you should just drop the equation of f of x there. I don't know why I'm so clumsy with this question. It's weird. But anyways, you see, this is what we have done so far. And this is like lim h goes to 0. Is it just me, or like the more I write, the more my handwriting just becomes worse? Wow. Yeah. And then we just multiplied the 7 inside. This is negative 4 minus 7x. The whole thing is still over h. So this is one of those simple first principles examples, because I mean there's literally not much to this question, you see. So here, this cancels that, this cancels, whoa, you see, error. Yeah, this is good, because you see that I did not put the brackets there. That's why we have an error here. And we were able to spot this error because this is supposed to cancel with something. You see, it's literally a trend. And you see how I actually did it before actually noticing that this was an error, because it's just a trend. Your values here, which are for f of x, they should always be cancelling something else in your expression, you see. So here you would have multiplied in, you'd have had negative 4, and multiplied in again, you would have had a positive 7x there. You see, this is fixed. There has to be stuff being cancelled out here. If you're not cancelling stuff out, there's definitely something wrong. So here now, we are technically going to have here minus 7h over h. And then with this example, you can see clearly that we don't have to throw in our value for h there, you see, because this will just cancel this. And then here we have f prime is equal to 7, which makes all the sense in the world, because you see, this is just an equation of a straight line. Now the equation of a straight line has a fixed gradient. You see, we can see that the gradient there is just a negative 7. So moving on to the next question, we have here, they said we should determine the derivative, or we should determine dy over dx. You see there, we should determine dy over dx if y is equal to 4x to the power of 8, okay, plus square root of x to the power of 3. Okay, that's an okay question, even though it has, you know, like a big exponent and, whoa, why do I keep doing that? Even though it has like a big exponent and all that, it's really not a big deal. It's just simple marks here. So we got our 4 marks there, and then we're definitely going to get these 3, because this is, you know, a very straightforward question. So our value for y is equal to 4x to the power of a positive 8. Yeah. And then we have plus square root of x to the power of 3 there. So yeah, that's okay. That's an okay question. Let's just get those marks and move on. So this is those moments in your exam where you need to make up for all the time that you may have lost in like other questions that were difficult. You see, these are simple, so just look out for simple errors and just, you know, go through them as best as you can, as fast as you can, but without like rushing, because I mean, yeah. So here, what's wrong with me? Wow. Here we need to have here 8 times 4, right? Of which 8 times 4, we know that's just 32, x to the power of 7. And then here, big problem. You see what happens when you just jump into differentiating. You end up, you know, just being stuck, because this is a problem. But to start off, right, this is what you would want to do before you differentiate. You want to simplify your expression as best as possible, in the sense that here, this is how you simplify anything with a square root symbol. There's like a 1 there, and then this one technically no. There's a 2 there. What in the world is going on? Oh wow, I should calm down. Relax. So this is, if you can note, you see, after going through your exams, like while going through your paper in an exam, obviously halfway through or towards the end, your brain is going to start becoming mushy a bit. I think this is proof, because what am I even saying? So here, anytime you see that there's no value here, you see in our main question, we were not given a value here. Now, as long as there's no value there, it automatically means that the value there is a 2. You see, just like what we did there. We need to put a 2 there. Now, when you simplify this before differentiating, this 2 goes under the 3, which is just 3 over 2. And then this we can differentiate now. If you want to differentiate this, now it's going to be nice and simple and straightforward, you see, without getting any hiccups, because I was about to just carry on without showing steps, which is, not going to be good for what we're trying to accomplish here. So this is 32x to the power of 7. Now here, 3 over 2 times 1 is just 3 over 2 with x, and then this whole value minus 1, that's just a half, you see. This will give you a final answer. With most of your memos, you will see that what they'll do is, if you have something with a surd in the beginning, they will always want to, have your final answer as a surd as well. Not like you should have it. I'm saying your memos will usually end up with, answers that have surds if you started off with surds. So this here, you would not want to be surprised if you end up with something like square root of x here, you see, because the 2 would go out again, and then the 1 is just a value there. You see, it's just reversing this process that we did in the beginning. You see, the 2 that was out went in to being the denominator of 3. Now here, the 2 will just go out, which is a value here. You see, if it's not there, it means it's automatically a 2. So the 2 will be here, then a 1 there. So this is just for interest sake. It's not necessary. This will get you all your 3 marks. So you get those 3 marks, and then you keep on going. Now here, we are given another basic differentiation question there. So remember, as mentioned, at this point in time, this is just one of those moments in your exams where you just need to catch up on time, because the questions will be fairly simple. You see, they want us to differentiate this. They said here, we're given this expression, we should determine dy over dx and dy over dA. Now this, for 7.3.1, that's technically just asking us to differentiate. So if we're going to differentiate in terms of x, it basically means that dy over dx is just going to be 2 times a, which is like 2a x, and then here, because you see a is our coefficient, so 2 times a is 2a, and then remove 1 from the exponent, that's just a 1 there. And then here we know that a is just a constant, so that just falls away. So this is our final answer, and you see that's why they're just giving you 1 mark for that, because yeah. Now here we should differentiate in terms of a. You see, so what that means is, when you differentiate in terms of a for 7.3.2, you see your main expression looks like this. Differentiating in terms of a, you could even rewrite it like this, where x squared is in front, because x squared is now your coefficient, a is your main variable. So differentiating this now, dy over dA, you technically have 1 times x squared, which is x squared, and then 1, whoa, what's going on? Yeah, it looks fine, I guess. So yeah, 1 times x squared, which is just going to be x squared, and then remove 1 from the exponent. The a will not be visible there because it will just be a 1. And then here we know that you technically have 1 times 1 there, which is just a 1. And then 1 minus 1 there will just give you a to the power of 0, which is just not necessary to write out. So this is what dy over dA will be if you differentiate it. It's just going to be x squared. Why did I put the 2 all the way up there? Weird. And then, wow, I know my handwriting is terrible, but this is not even a handwriting issue. It's just a weird way to put things. What am I doing? But this is 100% correct. This will get you all your 2 marks because we just differentiated in terms of a here. So you do that and you move on. So it says here now for 4 marks. Let's tick these things that we got here. Marks. So the next thing says, they say it here 7.4, the curve with equation this passes through the point A, determine the equation of the line perpendicular to the tangent to the curve at A. Okay. So it's a tangent question, which is expected for, differentiation or for calculus and all that. So basically what's happening here is we have a curve with this equation, right? So you don't necessarily have to say that you are dealing with, a specific kind of graph or whatever. It doesn't matter what kind of a graph that is. What matters is this equation, it passes through point A, right? They want us to determine the equation of the line perpendicular to the tangent to the curve at A. So technically, we need to find the line that is perpendicular to the tangent of this curve at this point. Now, we technically want to get the... Well, let's just take things slow. Let's not jump into things too abruptly. I hope I pronounced that correctly. So whatever line we're looking for, we know that it's a straight line graph. And this straight line graph has a standard form of y is equal to mx plus c. Now, this line that is going to be perpendicular to our tangent, what you want to think to yourself is just imagine like a random curve. Let's just excuse my curve here, my random curve. This is not a cubic graph, it's just literally a random curve. What I'm trying to say is, say we have a tangent here, right? This tangent, let's draw a straight line going there. So this tangent at this point, we know that the gradient of your tangent will be equal to the gradient of your curve at this specific point. Now they want us to get the equation of this perpendicular line, as in this dotted line here. This is what we're looking for. So for this dotted line, we know that it will pass through A as well, which is fine. A, they told us it is 2 coordinate B. Why did you have to make things so weird? Well, before we even carry on, right, let's just get a full coordinate for A, because why not? You see, this is X, this is Y. So let's just get a full coordinate for A. That's going to make our lives a bit easier. So to get a value for B there, we technically just know that in our equation, where X is, we should just drop a 2 there. And then this is clearly showing us that the corresponding Y value, this is 2 plus 6, which is 8. So Y is 8. So let's just finesse this quickly. Excuse me if you don't like what I'm doing, like how I'm just like, yeah, I'm botching stuff. So we have a full coordinate of A here, which is perfect. Now, our straight line graph passes through this point, which is cool. We need a gradient. Now, to get a gradient, we need the gradient at this point here. Ooh, things are about to get interesting. Well, not so much, really. We need the gradient at this point. So for us to get the gradient of this point, for this straight line, for this curve, whatever this curve is, we just need to differentiate that curve. So this curve, let's just get dy over dx for that curve. So getting dy over dx, we firstly need to write this equation in a way that we can simplify. So we can write it as y is equal to x plus, let's put the x up, this will be 12 with x to the power of negative 1. You see, this is what we can do for questions where you have your x as the denominator and you want to differentiate. You have to take it up, and then its exponent, you have to make sure it's a positive there. And then here, now we can differentiate. You see, this is easy to differentiate now because dy over dx, it's just 1 times the coefficient, which is just 1, and then 1 minus 1, it means this would just be a 1, so you don't write it. And then negative 1 times 12, that's going to be a negative 12. X to the power of negative 2. You see, I'm not even writing on the line anymore. Wow, that's rich. So we have differentiated our equation, and we want the gradient at this specific spot. So in our gradient equation, because we need gradient, we need to give this gradient equation an x value to work with. So we want the gradient where our x value is a positive 2. So our gradient here, let's see here, let's put here m for gradient. Oh, no, let's not be too fancy. Gradient. This is so unnecessary. Like, why am I doing this? Let's just put dy over dx. Wow. Yeah, I'm becoming too much now. I should relax. So in your calculator, right, we want to just work this value out. Now 2 to the power of, where am I getting 8 from? Wow. Yeah, I'm not even gonna laugh about this one because this is just weird now. Like, where am I getting 2 from? I'm sure you were asking yourself, where in the world is this dude getting an 8? I don't know where that 8 came from. So this here, it's technically just 1 minus 12, and then this value here in your calculator, it is just a quarter, you see. This value is just a quarter. So you have 1 minus 12 over 4 This is just 1 minus 3, which is just a negative 2. So what we know is that the gradient at this point is a negative 2. However, the gradient of our line that is perpendicular to this tangent, its gradient, we would need to do this m1 times m2. We know that this equals to negative 1 for lines that are perpendicular to each other. So our m2 is technically going to be a positive a half if you divide both sides by negative 2, you see. So we now at least have the gradient of our straight line there that we're trying to work towards. So I don't know why I didn't start that question on a new piece of paper, because I mean, why not? So technically what we have so far, right, is we know, we know that y, let me just put this here. Yeah, so here we have y is equal to technically a positive a half x plus c. You see, that's the equation of the line we're trying to work towards. So, and we said with this line now, we know that it passes through the point 2, coordinate 8. So we have x here, which is a 2. Our value for y is just a 8. And then a half times 2, that's just 1. And then clearly our value for c is just going to be a positive 7, because the 1, you're just going to take it over. And then it is going to give you a c value of a positive 7 there. So the moment you have your value for c, well, technically you can then say therefore y is equal to a half x plus 7. That's your final answer. So this one you can do a mini victory dance in your head, because I mean it was an okay question. It was not difficult, it was just okay, worth celebrating after being done. So let's see here. We just need to keep on moving. So I see here we have optimization. Interesting. So it says here, after flying a short distance, an insect came to rest on a wall. Thereafter, the insect started crawling on the wall. Okay. Thereafter, the insect started crawling on the wall. Oh, wow, this is dope. I can use the shadow. Let's see. Oh, no, I can't. Oh, yes, I can. Ooh. I should stop playing. Therefore, the insect started crawling on the wall. The path that the insect crawled can be described by this here. Okay. And then they said where h is the height in centimeters above the floor, and t is the time in minutes since the insect started crawling. Okay, so this equation basically gives us the height on the height up the wall, if we know how much time has passed since it started crawling. So that's interesting. And this is an 8-mark question. You see, close to, yeah, roughly 7% of your paper, which is cool, pretty cool, really. So here it says, at what height above the floor did the insect start crawling? And you see, it's just a 1-mark question there. So that's an interesting 1-mark question. So what we do know is, in our equation of h, the one thing that they mentioned is that h is just, this equation is going to give us height if we give it a specific timestamp. And again, speaking of timestamps, if you want to go through a specific topic, just check in the description for like the timestamps of like which topics are where, and then you can just jump to that if you want to. But anyways, here we know that they're asking what height above the floor did the insect start crawling. So technically, when the insect starts to crawl, no time would have passed. So it would have started when just before it starts crawling. We know the time is 0, you see. So where t is, you're just going to drop as 0 there. This is going to be 0 minus 6. And then here you have negative 2 with 0 here, squared plus 3 with a 0 there. And then minus 6 there. So all these values, right, you want to put them nicely in your calculator. And the keyword here is nicely, because again, don't lose marks for doing things, you know, in like a yeah, just get your marks, you know, don't do silly things in a paper and end up losing your marks, because it's really not necessary. So yeah, we can just put 36 there. We don't have we have a unit there. It's in centimeters. So you can put your answer as 36 centimeters. That would be perfect. 8.2 says, how many times did the insect reach the floor? Wow, getting fancy, I see. So we have 1 mark. Let's see here. How many times did the insect reach the floor? So technically we know that every time the insect reaches the floor, the height above the wall is 0. You see, because whenever it's at the floor, the height up the wall is 0. You see, because we technically have here a wall. Let's have a wall here. Well, walls are made of bricks, most of them, unless, you think of Legos, but it's a story for another day. So we have this wall. So technically, when it's at the floor, the height is equal to 0, you see. So if we're going to work out how many times did the insect reach the floor, what we can do is we can make our value for height here 0, and then work out how many t values will be balancing that equation. So what we mean is for 8.2, right, what you want to do is your equation, why am I putting equal to already? Where height is, you're just going to put a 0 there. And then on the right hand side, luckily this is already factorized. So you see one less problem out of the way, or one less marks to get freely because factorizing your cubic functions, it's something you want to be very comfortable with, because I mean, why be not comfortable with something that is definitely going to be in the exam? So yeah, so this is factorized. Technically, our first bracket is equal to 0, which is t is equal to 6, or this here, we need to factorize this. And as mentioned, I always use the quadratic equation because the quadratic equation saves lives, and yeah, man, I want my life saved. Pun intended. So this t is equal to minus b plus minus b squared minus 4ac. C here is a negative 6. Ooh, I can already see that we have bumped into a problem here. I'll tell you why just now. So the problem here is, you see here, we have a negative 2 times a negative 6. This is going to give us a 12. 12 times 4, that's 48, you see. And 48 is bigger than 9, you see. So 9 minus 48, that's going to be a negative number under a square root. So this thing here automatically has no solution. You see, in your calculator, if you put all this in there, you will find out that you will have no solutions there, because yeah, this is 48. So 9 minus 48 is a negative number, and you cannot have negative numbers under a square root unless you're working with complex numbers, but you don't have complex numbers in grade 12, so let's forget about that. Or imaginary numbers or whatever, but let's move on, because yeah, why am I talking about that when it's not necessary? Like, goodness. So t is equal to 6, and t here, there are no solutions. So this is telling us that technically our insect reaches the floor once, because there's only one timestamp where the height is a 0, you see. So to cement your answer for 8.2, you did need to say therefore once. I was about to say therefore it reaches the floor once, but why? This is your calculations. Once is good enough. Just writing there once is good enough. So the reason I'm doing this in this memo is I just want to give you an idea that with your papers, yeah, they don't want you to do things that are just weird. Your answers just need to be straightforward. The question asked, how many times did it reach the floor? It reached the floor once. So that's all you have to say, once. And then your calculation here is your proof. So you don't have to add a whole paragraph, whatever. That's really not necessary, because you see, that's more time. And remember, every second counts. So you move on. So 8.3 says, determine the maximum height that the insect reached above the floor. Okay, we need to get the maximum height. This is a height equation. Perfect. Or rather, let's do this. This is a height equation. Now, this height equation can get us height if we give it a timestamp. So we technically need to work out a value for t where the maximum height is occurring. And you see, questions where they ask for the maximum or the minimum or anything like that, they are the easiest questions you will have to answer in applications of calculus grade 12 or calculus grade 12 questions. They are some of the easiest questions you'll ever have to answer because you answer them the same way all the time. If you want to get the maximum height here, you need to differentiate this equation once and then equate it to 0 to get a value for t that will cause the maximum height. And then that t value, you need to throw it into your height equation to get the specific maximum height. So here they didn't ask what value of t will cause the maximum height. No, they asked for the maximum height itself. So we have to get the value for t, and then we have to throw it into this equation. So to get the value for t where the maximum height is occurring, well, technically we see that here our equation of t, that equation is not in a format that you can differentiate in grade 12, you see, because in grade 12 you don't have multiple ways to differentiate. You literally have like one way. So that one way, for it to work, we would need to just FOIL this. Not FOIL, we just need to multiply inside first. So this is 2t to the power of 3, negative 2t to the power of 3 rather. And then this is going to be positive 3t squared, and then minus 6t. And then this is like negative 6 times that. That's like a positive 12t squared. And then this here times that, that's like negative 18t. And the negative 6 times negative 6, that's like a positive 36 there. Now this we can just simplify it if you want, well, which is advisable, because why not? I mean, don't you like your life simple? So 3 plus 12 there, that's like a 15t squared, and then negative 6 minus 18, that's going to give you negative 24t. And then here this is plus 36. That's perfect. And then here now we can differentiate. You see, this is still not differentiated, but the moment you're going to differentiate, it's best to put like this apostrophe here. This is an apostrophe, right? Yeah, I think so. So 3 times negative 2, that's like negative 6 with t to the power of 2 there. 2 times 15, that's a 30. You see, I wrote 13 because 13 sounds the same, but it's actually 30, not 13. So yeah, no silly mistakes. No to silly mistakes is the name of the game. Hashtag no silly mistakes. That's a cool hashtag. Oh, no. That's a cool hashtag. Yo, mincing my words here. I think I should get a t-shirt that says no silly mistakes. That would be funny. But anyways, moving on. Yeah, we have differentiated. This differentiated equation, we need to equate it to 0. And then after equating this differentiated equation to 0, we need to solve for t. Now here you can divide by 6 if you want, but I usually just don't. I just, throw these values like that in your quadratic formula because, yeah, you can do stuff like that. So let's throw all these values into our quadratic formula. B squared minus 4ac. So this looks like it is also, well, this doesn't look like it's going to give us an error because 24 is 24 times 4 times 6. That's going to give you a number that is not so big because, 30 squared, that's like 30 times 30. And 30 times 30 is bound to be like a big number. So we're okay. So here, if you throw all this into your calculator, we're getting that your value for x, you're going to get here a positive 1 or a positive 4 if you throw all this into your calculator. So you see you're getting two values. The reason you're getting two values is because questions like these, they could have also said determine the minimum height that the insect reached. No, they could have also said determine the minimum height that the insect reached or something like that. If they'd asked for the minimum height, you would have still done the same thing, you see. So what this is telling us is these two values for t. One of them is for the minimum height and the other one is for the maximum height. So yeah, that's just, looking a bit creepy there. So all you want to do is, firstly, you want to ask yourself, why do we have a 4 there, and why do we have a what you call, what is that thing, and why do we have a positive 1 there? You see, we have two things. We have a 4 and we have a positive 1. So you just want to test both out. Well, so this is what I mean. In your expression where t is, just throw in a 1 there, get an answer, and then throw a 4 there, get an answer, and then just check which one is the biggest one. That's the easiest way to do it, you see, without being fancy or anything like that, because there are other fancy ways to do it, but why be fancy when you can just be simple and still get your marks? So if you want, right, let's see here. So this is going to give us -2 with a 1 here, squared, plus 3 with a 1 there, and then this is technically -6, and then let's see here. So this is like -5. Wow, why am I not just using the calculator? Well, the funny thing is I actually don't have my calculator with me right now. It's kind of far. So when I get it, I'll have to pause and then, yeah, carry on. But let's just do this quickly. -2 there, and then plus 3, and then this is -6. And then this is giving us -5 outside. -3, -2 plus 3, that's negative. That's +1. -6, that's -5, you see. So this is -5 times -5, that's just 25. So if you were to put a 4 in there, yeah, let's just get a calculator. Okay, so let's put those values into the calculator quickly. Let's see here. So we would have had here h with the 4, because remember what we're technically doing here is we're testing which values for t will produce the maximum height. You see, so this height here is producing, this value for t, which is 1, is producing a height of 25 centimeters. Now the value where h is a 4, let's see what that's going to do. This is going to be 4 minus 6, right? And then you're going to have the -2 with 4 there, the whole thing squared, plus 3 with the 4 there, and then -6 like that. Okay, let's see what this looks like in our calculator. So let's see that calculator. Whoa, why are you falling? So calculator, let's see here. We have these two, we have a bracket, 4 minus 6, and then we have the, why does it keep sliding? Wow, what did I just press? -2 with, whoa, don't shine the light on the screen. Why are you doing that? No. Wow, being so difficult, this light. Yeah, here I think you could see, yeah, there we go. So this is like 4 and the whole thing squared, and then we have plus 3 there with the 4 here, and then -6 like that. Ooh, 52. Whoa. Yeah, this is creepy. Well, let's just double check our calculator stuff. Let's see here. Okay. That's kind of crazy. So we're getting here a height of 25, and another one has a height of what is that now? 52. So let's see here. This is equal to 52, right? So I mean the proof is in the pudding, really. We don't have to to do anything funny, you see. It's straightforward. This is going to be our maximum height here. So our maximum height is equal to 52. This, you disregard it, and then this, that's your answer. This is your maximum height, you see, because the question was asking us to determine the maximum height that the insect reached above the floor. So what you do is you get your value for t, where the maximum height is occurring, and then that value for t, all you need to do is you need to throw it into your equation and then get the exact value for your maximum height, which is in our case 52. So yeah, this question is okay. You answer it and then you move on. There's really not much to it. With the next question, right, which is question 9. Question 9 is Cubic functions. Okay. So as you can see, things do start to get a bit better towards the end, because I mean, these are some of the comfortable things, you know, cubic functions, differentiation, and you want to become a fan of applications of calculus, because why not, you know, why not? So here we have a cubic function. It is a blunt cubic function. They said solve for this equation. Okay, it's a 3-mark question. Solve for this. Solve f of x equal to f prime. Okay, that's easy marks, I guess, because here, whoa, we have to take our marks. Tick. Yeah, that's very unnecessary, but okay. So we need to solve this equation. F of x, where is it equal to f prime? And then, yeah, that's what we need to solve. So, I mean, technically we have this already, so we just need f prime. F prime is literally just going to be 3x. Whoa, what am I doing? 3 times 3 is a 9. And then 3 minus 1 is a 2. So this is what f prime looks like. Whew, that's better. So here we have f of x, which is 3x cubed. Where is it equal to f prime? So remember, you may be asking yourself, what is going on? Why are we working out this when f prime is the gradient equation of f? Yeah, that's fine, because remember, this equation is just going to be a basic cubic graph. You see, it's just going to be a basic cubic graph. It's actually going to be very sharp, this cubic graph. It's going to look something like this, you see. And then our equation of our what? The equation of our derivative will look, well, it's technically going to be a parabola, so it will look something like that, you see. So they want us to work out where they will meet. So they will meet in 2 places, obviously. And if you're not familiar with, you know, the derivative of a function, you can always just check that out on the other channel. The other channel, again, if you're not familiar with it. If you are, you can just, yeah, give yourself a high five for subscribing. Bright young brains. This is the other channel with, like, you know, better tutorials and all that, like bite-sized tutorials. They're actual tutorials, unlike, you see, now we're working on past papers. Because when you study for an exam, you go through content, you know, I mean, no, you go through the work and then you have to work on past papers. You see, you don't go write a paper without going through past papers. That's the worst recipe ever. And yeah, so you want to time yourself and all that, you know, simulate the whole paper when you are studying, and then mark it, and then see where you got wrong, and then write another paper. So I would say, this is going to sound weird, but write at least like 3 papers before you write your actual exam. 3 papers may sound like a lot, but trust me, it's all worth it. 3 papers for each paper, obviously. So it's like 3 paper 1s, 3 paper 2s. That's just a random number, really. You don't have to do 3. I'm not saying if you do 3, you'll get a distinction or anything. No. That's not how it works. But technically, it could work like that. Yeah, okay. Enough blabbing. Let's go. Wow. Where do these meet? We just need to solve this equation. So technically, this is going to be 3x cubed minus 9x squared equal to 0. So we can factorize this here, because 3x squared is a common factor. So here, this is just going to be x. And then here, this is going to be 3. You see? Because that, if you multiply inside, it's going to give you this. If you multiply inside, it's going to give you that. So here it is technically saying, therefore, 3x squared is equal to 0. Excuse me for this. Ooh, don't hate me. I'm sorry. Let's just rewrite it here. 3x squared is equal to 0. Or x minus 3 is equal to 0, you see. So technically what's going to happen here is you're going to have the x squared is equal to 0, because if you divide by 3 on both sides, and then here you're technically having x is equal to 0 as one of your solutions. Now for this one here, you're technically going to have x is equal to positive 3, you see. So this is one of our solutions. This is our other solution. So that's it. You see, that's why they only made this question a 3-mark question, because there's really not much to it, you know. You get your 3 marks, and then you move on. Let's see here. Question number 9.2. Yeah, let's move this over to the side. Hey, what's going on here? I want to move it over to the side. Move it over to the side. So 9.2, right, says the graphs of, wow, so many graphs. Wow, people, wow. So it says here the graph of f, which is the original graph, and then f prime, which is the first derivative, and what is this? The second derivative, you see. We have f prime, and the second derivative. Interesting. They say here the graphs of these three all pass through this point. Makes sense, makes sense. Because we said, you see, this cubic graph, because there's nothing else here, it's going to be very sharp. And then this is going to be your derivative there. And then your second derivative is literally going to look something like, I don't want to jinx it. Well, it's obviously going to be a positive straight line graph, you know, somewhere there, something like that. Let's see, will it pass our turning point? Let me not jinx it. Let's just not do those funny things. So we have these three graphs, right? They all pass through 0, coordinate 0, which is fine. The first question for 1 mark. Okay, 1 mark. Whoa. What am I doing? Forgot to take this. For 1 mark, they said there, for which values of the graphs will 0... Wait, for which of the graphs? Okay. For which of the graphs will 0, coordinate 0 be a stationary point? Okay. So with 9.2.1, the key thing is, you see, that's just a 1 mark question, because they technically know that f of x is a cubic graph. You see, it's going to be a weird cubic graph that looks something like this. And then f prime is going to be a parabola, you see. And then your second derivative, it is going to be a positive straight line graph. So that's one thing to take away from our question. And if you want to go through again a tutorial on the graphs of the derivatives of a function, then you can look in the other channel. But then we're going through it now, you see. So they say it here, for which of these graphs will 0, coordinate 0 be a stationary point? Now, firstly, they said all these graphs pass through 0, coordinate 0. So we could say that this one passes through 0, coordinate 0 somewhere there. And then we could say that this one passes through 0, coordinate 0 somewhere there. And then this one 0, coordinate 0 somewhere there. Now, you can clearly see that firstly, with our three graphs, right? One of them has, we said one of them is a cubic graph, the other one is a parabola, and then clearly that last one there is just, well, I mean, like, that's a straight line graph. Why did I even have to pause for that one? Because I mean, like, it's a straight line graph. There's literally no guessing there. So to answer this question, what you want to keep in mind is, firstly, so they said which of these two graphs will have a stationary point at 0, coordinate 0. So this is going to need you to have a bit of background on, you know, cubic functions and everything like that. Now what we know is, for a cubic function, they said that it's going to pass through 0, coordinate 0. And then here we are clearly seeing that our original graph and our first derivative meet at 0, coordinate 0 as well, technically, because you see they meet where an x value is also a 0. So yeah, that's just very weird. So, well, to just answer this question for 1 mark, our cubic graph here will have a stationary point where this is equal to a 0. And then our straight line graph will also have a stationary point where x is equal to a 0. Because here, this will be the point of inflection of your cubic graph. This will be the turning point of your parabola. With your straight line graph, I mean, this won't have a stationary point because it's a straight line graph, you see. This has a stationary point here where x is equal to 0. The reason for that is your cubic graph. If you differentiate it, we know that you're getting this parabola here. Now the turning point of your parabola will always give you the point of inflection, or rather, no. Actually, yes. The turning point of your parabola will always give you the x value of the point of inflection of your cubic graph, you see. So if this turning point is where x is equal to 0, it automatically means that our point of inflection for our curve is going to be where x is equal to 0. And a point of inflection is a stationary point. A turning point is also considered a stationary point. And if you want, again, just a rundown on stationary points, I promise you that's in the other channel, in the Calculus Grade 12 playlist. So for this question, for 9.2.1, you're just going to say both f of x and f prime. Yeah, I think I'm abusing this bad handwriting thing. Like, seriously, I should get it together. So that's for 1 mark. Again, if these are the kinds of questions that won't give you like a good feeling, well, just move on, finish your paper and then come back to them. It says you explain the difference, if any, in the stationary points referred to in 9.2.1. Okay, that's quite interesting, because we already mentioned what's going on here. We said 9.2.2. We said, so here we need to remember stationary points are both turning points and your point of inflection. That's what stationary points are. So here you can see that for f of x, the stationary point is a point of inflection. And then for f prime, it's a turning point. You see, because when we say stationary points refer to points of inflections, or rather, stationary points refer to a point of inflection and a turning point. Those two together, you refer to them as stationary points. So we have one kind of stationary point here and another kind of stationary point. Here we have a point of inflection, and then here we have a turning point. So let's move on with the next one, which is 9.3 here. It says, and remember, if you have any questions on anything, you can just send me a DM on IG, and then I'll be able to help you out 100% all the day long. It says you determine the vertical distance between the graphs of f prime and the second derivative at x is equal to 1 for 3 marks. Okay, we're about to get these 3 marks. We got these 2, we got that 1. So if you want to work out the distance, the vertical distance between f prime and the second derivative of f. So you see this sketch here, this was a rough sketch, very damn rough sketch, because our 3 graphs, well, technically you're going to have your squiggly line, right? Your cubic graph that looks weird, and then here you're going to have your turning point, your parabola somewhere there, and then you're going to have your straight line somewhere there. So this is not necessary. I don't even know why I'm doing this, but wow. Back to our question. It says you determine the vertical distance between the graphs of f prime and the second derivative. Okay. So technically f prime is our parabola, right? And then our second derivative is just a straight line graph. So we have a straight line graph here, which is our second derivative. We have a parabola here, which is our first derivative. And then here they said somewhere here, we know that somewhere here the x value is equal to 0. I mean, that we know. And then technically, let's actually do it here, because why am I doing there? Somewhere here we know that the x value is technically going to be a positive 1. So they want us to work out this distance here, the distance between this and that. You see, that vertical distance is what they want us to work out. Because if you check the question, determine the vertical distance between the first derivative and the second derivative at x is equal to 1. Now the good news is anytime you need to work out the vertical distance between 2 points, like anytime you need to work out the vertical distance between 2 points. Did I just repeat the same thing twice? Wow. Anytime you need to work out the vertical distance, between 2 points, all you do is you need to ask yourself, between these 2 points, which one is on top? Well, technically the first derivative is on top, and then the second derivative is at the bottom. So the distance between these 2 points is literally going to be the graph that's at the top minus the graph that's at the bottom. You see, this is always going to give you your vertical distance. This is like, yeah, it's not a formula, but it's just, over time you'll note it is just logic, because you see the y value here, which is being represented by this here, minus the y value down here, which is being represented by this here. Technically, if you say the y value here minus the y value there, you'll have the distance here, you see. So here, that's what we're going to do. This equation minus this equation will always give you distance. And it's all a matter of asking yourself which of them is on top and which of them is at the bottom. So the one at the top is our first derivative, which we will need to get, which we kind of did get. Our first derivative, if you remember, it is just 9x squared there. So here we have 9x squared as our first derivative. Technically, our second derivative is then going to be 18x, you see, because this differentiated is that. Yeah, and try not to get confused at this point, because all we did here was we have a first derivative here. A second derivative is technically just going to be 18x, you see. So that's all we're doing here. First derivative minus second derivative is going to give us our distance. And you see, we will have our distance if we know the x value where this is occurring. That's the other thing with questions like this. That's why it was important for them to tell us that x is a positive 1, because this works if we know the x value where the lines, if we know the x value where the points are. So here our x value is just a 1. So you put a 1 where x is, and then here our distance. There we go. You see, you don't need, if you wanted, you could have literally worked out the y value there and the y value there, and you compare the two. That's what this is literally doing. You see y value here comparing with this y value. This is squared, but that's clearly not going to make a difference. Wow. Why are we getting a negative number? Yeah, this is not fun at all. Like, well, so let's see here. We're getting a negative value technically, because our answer here is going to be, well, literally, technically we're getting the -9. And we know that -9 cannot be, what do you call it? -9 cannot be an answer. So, yeah. What that could mean is that, what could it mean? What could it mean? Well, the good news is we know that distance will always be a positive number. So here, the last thing you want to do is don't leave this as your final answer. You need to say, therefore, let's see here, what did they ask? Determine the vertical distance. Therefore, a vertical distance equals a positive 9, right? And then you can add a side note if you want here. Distance cannot be a negative. You see, if you do physics, then, well, this has nothing to do with physics. This is just a unit, and when we work with distance, you always take the absolute value of your number. The absolute value of -9 is just a positive 9, so this will be fine. You get your marks, and you move on to question 10. We are literally 2 questions away from finishing. Oh my gosh, this is so amazing. We did it. If you've been watching the whole thing, you know, you just hit me up. Why? Wait. Yeah, because I think that would be cool. Want to know like who literally just went through this whole thing? Like that's gonna be pretty dope. That's gonna be pretty dope. Yeah, that's just gonna be pretty dope. It would just be interesting to know like what you watched the whole thing. Oh my gosh, you're so cool. Give yourself a pat on the back. So, well, here we are. If you literally just came to this spot because of the timestamp, then welcome, welcome. If you have been watching the whole time, wow, you're dope. You're like proper dope. You should type in the comments, I'm dope, because when you reached question 10, I had been watching the whole thing. That's going to be proper dope. So, yeah, with question 10, it's a probability question. And okay, let's jump into it. Question 10 says that the school library, is open from Monday to Thursday. Okay, fine. That's very interesting. Why is it not open on weekends? People usually study on weekends. Well, most people don't, but I mean, now we have to study every day, so why not opening every day? But this library wants to only open on Mondays and on Thursdays. No, Mondays to Thursdays, which is fine. So Monday to Thursday, that's when this library is going to be open. Anna and Ben. If your name is Anna or Ben, let me know in the comments. So Anna and Ben both studied in the school library one day this week. Okay, y'all are not serious. But anyways, maybe Anna and Ben study most at home, or they study better at home, or whatever way. Let me not judge here. So Anna and Ben both studied in the school library one day this week. If the chance of studying any day in the week is equally likely, calculate the probability that Anna and Ben both studied on the same day. Okay, well, it's just a 2-mark question, so that tells you don't want to overthink anything, because why? So we technically just need to map this scenario out nice and slow, you see, because they said here we have Anna and Ben that go to the library. Cool. I last went to the library, yeah, a very long time ago, because I figured I'd study better at home anyways. So 10.1, they said, what is the probability that Anna and Ben studied on the same day if they only went to the library once, of which the library is only open for 4 days? Okay, so what you're trying to do is, I always like to work with sketches when working with probability or permutations or counting principles or whatever. So we have 4 days, we have Monday, Tuesday, Wednesday, Thursday. You see, let's put here Monday, Tuesday, Wednesday, Thursday. So what you want to ask yourself is, for Ben, you have Ben, let's put Ben and Anna here. You see, Ben, Anna, Ben, Anna, Ben, Anna. So I'm doing this because what you want to ask yourself is, for Monday, what is the probability that Ben goes to the library? Well, if he's going one day out of the 4, then the probability that Ben goes on Monday is just 1/4. The probability that Anna goes on a Monday is also just 1/4. Then you ask yourself, what is the probability that Ben goes on Tuesday? Well, Tuesday is one day out of the 4, you see. So Ben, the probability of going on a Tuesday is just 1/4. For Anna, the probability that she goes is also just 1/4. Then technically for all the other days, it's the same probability, because the probability of Ben going on this day is just 1 out of 4 days, you see. So that's fine. So all you want to do now is the probability of them going on the same day. Remember, these are independent events. The reason they're independent events is because if Anna and Ben, them going to the library, those are independent events because one does not affect the other, you see. So yeah, those are independent events. Well, the probability of them going on the same day, technically you want to think to yourself, what is the probability that they both go on a Monday? It is the same as the probability that they both go on a Tuesday. It is the same as the probability that they both go on a Wednesday. And it is also the same as the probability of them both going on a Thursday. So what you want to take note of is they are technically, technically there are 4 days when they could potentially go on the same day. So the probability of each day, what you want to do is the probability of them both going on a Monday. That's just a quarter times a quarter. Because remember, with independent events, the probability of A multiplied by the probability of B, this will always give you the probability of A and B, you see. So we know that this is the probability of Ben, the probability of Anna going, which is a quarter. The probability of Ben going, which is a quarter. So the probability of both of them going on this Monday is just 1 over 16, you see. So for each day, there's a 1 over 16 chance that they will both go to the library. You see, 1 over 16 for Monday, 1 over 16 for Tuesday and Wednesday and Thursday. So because that could potentially happen in one of these 4 days, you need to add all these probabilities, you see, because the probability that they go on a Monday is this, the probability that they go on a Tuesday is this, the probability that they go on a Wednesday, the probability that they go on a Thursday. So the probability that they go on the same day is just all these probabilities added together, because we worked out the probability of them going on a Monday, Tuesday, Wednesday, and Thursday. These are all potential scenarios. So because they all potentially could happen, you need to add all those probabilities together, of which this is just giving you 4 over 16. If you want to simplify and be fancy, this is going to give you 2 over 8, which is just going to be a 4 as the denominator and a 1 at the numerator. So your answer there will just be a quarter. So that's an interesting question. Whew. The next one says, what is the probability that Ben and Anna studied on consecutive days? Ooh, wow, these guys just keep bringing the hit. Well, it's a 3-mark question here. Well, this one was only 2. Wow, guys, that's so mean. Like, so much work, just 2 marks. Well, it's fine. You don't complain about it. Wow, dude, get it together. What the hell? So with 10.2, right, we need to work out the probability of them going on consecutive days. So to do that, all you need to think to yourself is, let's map out those 4 days again. You see, Monday, Tuesday, Wednesday, and Thursday. Monday, Tuesday, Wednesday, and Thursday. So you want to ask yourself, if they're going to go on, you want to work out the probability that they go on consecutive days. So all you do is you need to ask yourself that there are technically one of 2 scenarios. What I mean is, if Anna goes here, then for them to be going on consecutive days, Ben would need to go here. Or if Ben goes here, Anna would need to go there. Or if Anna goes here, Ben would need to go there. You see, this is the only scenario if they were going on consecutive days. However, we know that what if it's Ben that goes on a Monday? If Ben goes on a Monday, then Anna has to go on a Tuesday. However, if Anna went on a Tuesday, then Ben has to go on a Wednesday, you see. And then if Ben goes on a Wednesday, Anna has to go on a Thursday. Remember, we need to keep in mind that this scenario, Ben and Anna both studied at the library only 1 day during the week. The key word here is they only studied 1 day during the week. So hence why here we said if Anna goes here, then technically for them to be going on consecutive days, Ben would need to go here. If Ben goes here, Anna would need to go here. If Anna goes here, Ben would need to go here. Or if Ben goes first, then Anna would need to go on a Tuesday. However, if Anna goes on the Tuesday, Ben needs to go on the Wednesday. But then if Ben does go on the Wednesday, then Anna needs to go on the Thursday if they are going to be going on consecutive days. You see, before you work on probabilities, map out the scenarios in question, you see. So what we need to ask yourself is, well, technically speaking, this is one scenario where they have gone in consecutive days, you see. This is another scenario where they've gone in consecutive days. This is another scenario where they could have gone in consecutive days. And then down here, if Anna goes first, then this is one scenario where they could have gone in consecutive days. This is another scenario where they could have gone on consecutive days. And then this is another scenario when they could have gone on consecutive days. Yeah. So what we want to do is we want to work out the probability of this happening, you see. The probability of this happening, you just need to ask yourself, what is the probability that Ben goes on this day? It's just a quarter. What is the probability that Ben goes on this day? I mean, Anna, it is also just a quarter, right? Because, I mean, it's just one day out of the 4, you see. So technically, for this scenario to occur, it's going to be a quarter times a quarter, which is just 1/16, you see. Now here you do the same. The probability that Anna goes here is a quarter. The probability that Ben goes here is also a quarter. So the probability of this scenario occurring where Anna goes and then Ben goes is just 1/16. You see, if this is the scenario that played out, then the probability that Ben goes here is just 1/4. The probability that Anna goes here is just 1/4. So the probability of this happening is just 1/4 times 1/4 there, which is just 1/16, you see. Down here, it will be the same thing. The probability of this happening would be 1/16, 1/16, 1/16, you see. So this is clearly telling us that there are 6 chances that these guys could go on consecutive days. You see, 1 chance, 2, 3, 4, 5, 6 chances. So because there are 6 chances of that happening, we need to add up all these individual probabilities. So it's technically just 1/6 times 1/16 times 6, because you have 1/16 6 times, you see. This is just giving you 6/16. This is technically just, if you divide by 2 on both sides, this is technically just 3/8. There we go. That will give you 3 good marks. So you grab your 3 marks and you run. This was quite an interesting question. And again, the best part about YouTube videos is you could always just rewind and rewatch. And if you want a better understanding, you can always ask. I would definitely be able to help you out. Events A and B are independent. We're on question 11 now. We thrashed the previous one. I mean, murdered it. Moving on. Let's not use the word that. Let's not use that word. Let's use a nicer word. We crashed it. Crushed it, yeah. Crushed. 11 says events A and B are independent events. Okay, independent events. Very nice. So if you need help with independent events or probability in general, I mean, that's in the probability playlist on the Bright Young Brains channel. So help yourself out if you want to. So it says here the probability of A is just 0.4. The probability of B is 0.25, right? That's the probability of B. Oof, kind of just got interrupted, so I have no idea what I was saying before this. But I was basically trying to mention that we have the probability of A here and the probability of B. And yeah, with probabilities, if you ever get an answer that's bigger than 1, it's definitely wrong. But yeah, that's a story for another day. So here it says events A and B are independent. And we have A here and we have B here. And remember, excuse me, anytime you deal with events that are independent, before you even work on anything, just remember that the probability of A times the probability of B will always give you the probability of A and B. Let's just keep this in mind because, you know, it's important. They say it here, 3 marks represent the given information on a Venn diagram. Indicate on the Venn diagram the probabilities associated with each region. Ooh, easy 3 marks. Reason is they want us to draw a Venn diagram. So if you're going to draw a Venn diagram, you draw like a mini rectangle first. And here you see we're only working with 2 events. So you draw 1 circle for the 1 event, which is just A. And then because these are independent events, it means that they intersect somewhere, you see, because the probability of A and B is equal to the probability of A times B. So this is B here. And then technically, if this is going to be a Venn diagram of probabilities, with this Venn diagram of probabilities, it just technically means that our sample space, if you want to have a sample space there, your sample space is technically just the 1, which is just weird if you want to put it that way. This is not very necessary, but let's just put it there. The reason I'm putting it as 1 there, because in probability, everything has to add up to 1, so let's just throw that there for just to be funky. So here now, this is saying the probability of A is 0.4. What that means is this and this has to add up to 0.4. This is saying the probability of B is 0.25. What that means is this and this has to add up to 0.25, both of these, right? So if both of these have to add up to 0.25, let's just keep that in mind. So the easiest thing for us to do first before we throw in numbers here is to work out what is this value here, because we know that this whole thing is 0.4, right? However, if we know this value here, we can say the whole thing minus this value, we'll get this portion here. Same for that portion. So let's just get the probability of A and B. So to do that, you're going to have 0.4 times 0.25. This is going to give you the probability of A and B. Now 0.4, calculator, let's see here. 0.4 times 0.25, that's going to give you 0.1. So okay, 0.1. Probability of A and B, that's 0.1. Okay, so automatically it means that the center part here is just 0.1, and then automatically this has to be like 0.3, and then this has to be like 0.15, you see, because these two together have to give you 0.25. These two together have to give you 0.4. Now you're not done, because you see the outside also has to be accounted for. So technically this plus this plus this plus the outside has to give you 1. Hence why I think this is important. So for us to get what's going to be the probability of these events not occurring at all we need to say is 1 minus the 0.3 minus the 0.1 minus the 0.15. Let's see what's left. This is 0.45. So outside we have to put there 0.45. Then this will get you all your 3 marks. Clean 3 marks. And because you will be like close to the end, you would be thinking to yourself, you know what, I need to pick up the pace so that I don't just lose silly marks or so that I don't make silly mistakes and lose marks for, the easy stuff like here. They say here, what is the probability of A or not B? Okay. Fancy questions out here. They said, what is the probability of what? The probability of A or not B. Okay, that's quite an interesting question. So the one thing that you should take away from this question is it is literally just 2 marks. You see, it's a 2-mark question, and yeah, it's really not that bad. So what we need to do for ourselves is we firstly need to work out the probability of not B, because you see, this is not a hard question. The reason it's not a hard question is because we need to work out the probability of A or not B. This is what we need to work out. Now, if you use your general rule of probability, the probability of A or this, it is just going to be equal to the probability of A plus the probability of not B. Let's put here not B minus the probability of A and not B. This is your general rule of probability. And remember, your general rule of probability is something that is on your formula sheet. So on your formula sheet, you can always just work that out using, you can always work out this value using your formula sheet. So so let's just jump into this question. So the first thing we can work out for us to use this general rule of probability, let me actually just write it out here. We said here the probability of A or not B is equal to the probability of A plus the probability of not B minus the probability of A and not B. This is your general rule of probability. So we said for this to work, we have this value, which is fine. That's just 0.4. However, we need to work out the probability of not B. So the probability of not B is literally everything here that is not B. So the probability of not B is literally just saying 1 minus everything that B is. You see, like that. There we go. No. B is 0.25, you see. 1 minus everything that is B. This is giving us what is not B. You see, that's the funny thing with probability. Remember, not B and B are complementary events, you see, because the probability of B plus the probability of not B, this should be equal to 1 because these are complementary events, you see. Wow, yeah, so that's that probability playlist that is on the Bright Young Brains channel. That's definitely going to help out because, like, legit, with the probability work, went through all these in depth. So this is B, so the probability of not B is just 1 minus that value. So we have that now, you see. We have the probability of not B. Let's just jot it down somewhere. The probability of not B, that's just 0.75. So we have this, we have that. Now we need the probability of A and not B. So the probability of A and not B, this is basically saying where does the probability of A and the probability of not B intersect? Well, technically this question seems a bit weird, but everything that is not B is everything. Let me color it here. Let me just pay attention to the color, you see. So everything here is stuff that is not B. You see, everything here that I colored is things that is not B. You see, everything here that's colored is stuff that is not B. You see, excluding this circle only. You see, everything excluding this circle is everything that is not B. You see, this expression, this portion here is saying what is the probability of A and not B. So the probability of A and not B is the portion in our Venn diagram where the probability of not B and A meet. You see, so this part here is the probability of A and not B, because everything that is not B is out here. However, A and that space meet here only, you see. So the probability of A and not B is equal to 0.3. So yeah, probability questions are interesting because everything here is stuff that is not B, everything there. However, the probability of A and stuff that is not B meet here only, which is 0.3. So we have that value here as well, you see. So with our question, they want us to work out the probability of A or not B for 2 marks only. You see, that's why they are only making these questions 2 marks, 3 marks, because yeah, they're not too bad if you like know your work, right? Which is what you want to know, your work. So here in your formula, the probability of A or not B, this is going to be equal to A, which is 0.4, not B, which is, we worked it out to be 0.75, and then not, and the probability of A and not B, this is just 0.3. So let's see here. All this in our calculator. Let's see there. We're going to have 0.4. Why am I having brackets? The 0.4 plus 0.75 minus 0.3. This is just 0.85. So that's going to be your answer there. 0. Ooh, why am I? It's so weird. 0.85 is going to be our answer. You get your 2 marks. And then you move on because at this point you're literally almost done because you have like one last question. Okay, so if you'll note in your past paper, this was not the last question. This was like the second last question, you see. The last one is over here at the back. There we go. This is the very last question. Would you believe it? We're literally almost there. 6 marks away from 100. Must be nice. So with this next question, right, because we're on probability, it's probably going to be a permutations question, you know, with the counting principles and all that. You know, you can almost count on it being there because it's always going to be there type of thing. So let's see what they say here. They said Motors Incorporated manufactures cars. Okay, so we have a car manufacturing company here. It's called Motors Incorporated. Okay, that's a very clever name, not? It says here they want to manufacture cars with 5 different body styles, 4 different interior colors, and 6 different exterior colors. It's as indicated in the table below. Okay, so you have 5 body styles, 4 interior colors, and 6 exterior colors. Okay, that's very interesting. They said here the interior color of the car must not be the same as the exterior color. Okay, and then they said Motors Incorporated wants to display one of each possible variation of its car in their car showroom. The car showroom has there's supposed to be air. The car showroom has a floor space of 500 meters squared, and each car requires a floor space of 5 meters squared. Then they said here, is this display possible? Justify your answer with necessary calculations for 6 marks. Ooh, very fancy question, this one. So the one big idea with this kind of a question is that firstly, we would need to firstly work out how many cars are there possibly. And then we would need to think to ourselves, depending on the number of cars that are there, each of them is going to take 5 meters squared of space. So what we need to work out is if each of them takes 5 meters squared of space, will it be able to fit into 500 meters squared? That's what we need to do. So say we have like 10 cars in total, all right? 10 cars times 5 would occupy 50 meters squared of space, of which that would fit, you see. If we had 100 cars, then 100 times 5, that would be 500 square meters. So yes, they would fit. If we had 200 cars or something, you see, then 200 cars times 5, that would give us like 1,000 square meters. So that would definitely not fit. So that's what we're trying to do here. We need to work out how many cars are possible with these criteria. So the one big issue is if you're going to work out how many cars are possible here, can you see how we have like 6 colors to choose from? We have 6 exterior colors, 4 interior colors, and 5 body styles. So if you're going to work out how many possible cars can you have, or how many variations are you going to have, especially if they also told us that the interior color cannot be equal to the exterior color. Between these 3, right, you always want to focus more on the one with the least options. Make this one like your anchor, if I can put it that way. So what you want to do first off to work out how many cars are possible here, you want to lay out a scenario where you have these 4 different interior colors, right? Let's put here 1 interior color. This would be a set of the others with another interior color, the set of others with another one, the set of others with another one. So technically in this pool, let's put here all the blue ones, and then in this pool let's put here all the gray ones, and then here all the black ones, and then here all the red ones. You see, this is going to make our life easier. So you need to ask yourself, for the blue ones, right, how many body styles do you have for the blue ones? Well, technically for the blue ones, we have 5 body styles. You see, we have 5 body styles. And then you need to ask yourself, how many exterior colors do we have possible? Well, technically we have 5 because gold, red, green, white, and silver are all possible. Blue will not be possible for the blue exterior, or rather blue will not be possible for the blue interior, because you see the interior and the exterior should not be the same. So we can have blue interior, yes. However, the exterior colors that we have, we technically only have 5 options for the blue. Then you move on to the gray. You do the same thing. For the gray cars, we have 5 body styles, you see. So for the gray cars, why am I doing it like that? Let me just put this on top of it, like there. Then let's do this like that. You see, that's I think that's better. So here we have here for the gray cars. Let's do this. Wow. For the gray cars, we technically have 5 body styles. Wow, what's going on now? Right at the end, we are starting to have these weird things. We have 5 body styles for the gray. And then we technically have all colors available for the gray, so that's times 6. And then for the black, we have 5 body styles. And then let's see here if there's an exterior that's black. No, so all colors for the black are available. And then for the red, we know that we also have 5 body styles. However, we have a red exterior there. So you see the number of colors for the exterior, we only have 5 options because red is excluded, you see. So that's for the red cars. There we go. So you want to think to yourself, for the blue cars, we have 5 times 5. And then for the grays, we have 5 times 6. And then for the blacks, 5 times 6. And then for the reds, 5 times 5. You see, so blue cars, we technically have 25 variations. Gray cars, we have 30 cars that are gray. Black cars, we have 30 cars that are black. Red cars, we have 25 cars that are red, you see. So we technically have in total 25 plus 30 plus 30 plus 30, which is technically giving us, let's see here. These two is like 55. These two here is also 55, you see. So together, this is just 110. Don't mind me doing this. That's just weird. I should have just added all this using the calculator. So yeah, all these numbers added together is just 110 cars in total. Okay, so if we're technically dealing with 110 cars, and each of them takes up 5 meters of space, so it's going to be 110 cars times 5 meters squared of space. This is technically showing you that all these cars take up 550 meters squared of space, and you only have 500 meters available. So you see, here your answer is going to be point blank and no, because you worked it out. The number of cars times 5 meters, it's just not going to fit, you see. So here you're going to say no, because, well, yeah, no, because the cars, well, this is the last thing, so you can write a nice long sentence if you want. No, because, wow, yeah, my brain is definitely done. No, because the cars take up 550 meters squared of space. 500 meters squared, which is more than 500 meters squared. And then boom, 100% for a paper. Would you look at that? Wow. Yeah, that's like a lot of stuff that we went through, you know, like a ton of questions that we went through. And you can almost hear from the voice, from the tone of my voice for this last question, that yep, I am gone. So like we literally went through all these questions, like all these papers here is the past paper, you see. If you want PDF copies to all these, just let me know on IG, just hit me up, and then I'll definitely be able to send you all these. There are so many, I don't even know how many pages these are, but yeah, I mean, we did it, yay. If you watched the whole thing, if you legit know you watched the whole thing, That's like proper cool. You should hit me up, let me know. We we would be able to, you know, arrange something cool for you, I guess, because that's like proper dope stuff. Like, oh my gosh, like that's like proper dope. So yeah, it's all good. Cheers. So like legit, right? As I was like pecking away and stuff, I realized I legit skipped. Why do I keep saying legit? Well, I just realized I skipped 9.4 accidentally. So that's like proper proof that in an exam, yeah, 100% concentration is necessary at all times. You see, otherwise, yeah, you might just find yourself like skipping a question. And I mean, this is like 4 marks, so we technically did not get 100. Wow. But how did I tick this? Wow, this is odd. I don't remember going through this. Wow, weird. But yeah, with this question, right, we need to work out, it says here, for which values of x will this expression be smaller than 0? So all you would want to do is, firstly, our value for f of x, it is this value, right, which is just 3x cubed. And then our first derivative is technically just going to be 9x squared. So they're asking, where is this expression below 0? So technically, all you want to do for yourself is, let's factorize this, right? This, if you factorize it, it's going to be 3x squared with x here minus 3 technically. Where is that whole thing smaller than 0? So what you wanna, the way you answer these questions is, you wanna think of these as two blocks, right? These two here. You have two blocks, one block here and another one over here, right? You're multiplying two things, and they're asking you, where will that expression, right, where will this expression be a value that is smaller than 0? So we know that you can have an expression or a value that is smaller than 0 if you are multiplying a positive number with a negative, or if you're multiplying a negative number with a positive. You see, these are the only two scenarios. These are the only two scenarios for you to end up with an expression that is smaller than 0, you see. This value either needs to be a positive, but then at the same time this would need to be a negative, right? Or this value needs to be a negative, and then this value here needs to be a positive. So we technically need to work out, let's put here #1, scenario number 1. We need to work out where this scenario is playing out. So where this is a positive and where this is a negative, let's see. It's this is what we need to do. We need to work out where is this thing here a positive number, you see. Well, technically for this first scenario, 3x squared is a positive number everywhere, you see. It is a positive number where x is an element of R, because this can never be a negative number ever. Because whatever x value you throw in there, it will always pop out a positive number. So this will always be a positive number. X is an element of R. And then we need to ask ourselves, which values of x will cause this expression to be a negative, you see. So we need to work out where is x minus 3 going to be a negative, you see. X minus 3 is going to be a negative where x is smaller than 3. You see, where x is smaller than 3. However, the only problem with what we have so far, or the only hiccup, if I can put it that way, is that here we know that x has to be smaller than 3. Yes. However, if we think of all values that are smaller than 3, technically our value for x cannot be a 0, because if x is a 0 in this expression, it means that the whole thing here is going to be, you would have 0 here times that, which is just a 0, and you see 0 is not smaller than 0. So this is fine, you can have it there, but just put there x is not equal to 0, you see. So we know that for this to be happening, x is an element of R, and we know that our values for x have to be smaller than a positive 3 there, right? That's what we technically are concluding. However, we know that where these two can accommodate each other, it is only where x is smaller than 3 and where x is not equal to 0, because, well, technically speaking, for this to be a positive number, all x values are possible. However, for this to be a negative, you only need to consider x values that are below 3. So these two will both only occur if your x values are smaller than 3, you see. Because all x values that are smaller than 3 and not 0 will also accommodate a few values for this expression to be a positive. So that's what we can put there for our answer for 9.4. If you were to consider the second option, right, which is option number 2 here, and this question is most probably one of the confusing questions in this paper. So if it's not your cup of tea, then that's all good. And you can always just let me know on IG if you want a bit of clarity or anything. That's perfect. So for this portion here, we need to work out where is the left side a negative and where is the right portion a positive, you see. So firstly, for this to work out, we will need to work out a portion where the left is a negative and where the right is a positive. So the only thing is, you see, this portion here can never be a negative, because any value here that you will throw in, you will square it. And any value squared is always going to pop out a positive number anyways, you see. So this here will never be a negative. So this second scenario can never play out. So only the first scenario can play out, which is this being a positive while this is a negative, you see. So these two will accommodate each other where our x values are below 3 and x cannot be equal to 0, because you see, this is saying where can this be a positive? This can be a positive at all x values, so that's fine. And then here this is asking where can this be a negative? This can be a negative where your x values are below 3. Okay, fine. So these two only meet at x values that are below 3. And we need to exclude a 0, because we said if you throw a 0 here, you will have a 0 on the left, of which 0 is not smaller than a 0. So you need to disregard the 0 there. So for 9.4, for 4 marks, that is what you would have needed to do. So, yeah, if you want, well, if this was helpful, then you could give this video a thumbs up. And if you want, obviously, you could subscribe to the channel, because, yeah, we'll be posting other papers as well, and the paper 2 of the 2019 November paper after this one, obviously.